Ho paura.
Allora, incominciamo davvero. In primo luogo lasciatemi ringraziare il direttore generale, grazie Pasquale, il prorettore alla ricerca de nonno, decano, oggi avete sentito, del nostro Ateneo. E io sono un inguaribile ottimista, quindi cerco sempre di vedere in maniera positiva queste situazioni. La giornata odierna, a mio avviso, è veramente un qualcosa di positivo. Tra l'altro ho visto nascere sotto la mia direzione questa storia, e ricordo, come diceva il direttore generale, che sono stati giorni veramente assurdi, frenetici, nel mese di settembre-ottobre dell'anno passato, perché in pochi giorni sono pervenute queste risorse e bisognava in pochissimi giorni fare dei progetti, pensare delle collaborazioni, ragionare su come utilizzare in maniera significativamente utile. E questo ringrazio moltissimo l'Ateneo per aver capito che nel nostro Dipartimento si potevano trovare quelle competenze necessarie per sviluppare le tematiche green che erano richieste in quello specifico progetto. Non erano fondi a caso e che per fortuna nella nostra Unione Europea e conseguentemente nel nostro Paese abbiamo capito finalmente, dopo 30 anni che parlavamo, alcuni di noi, che la situazione è veramente difficile e che bisogna impegnarsi veramente su una transizione, una trasformazione nel modo di vivere e di ragionare. Conseguentemente la ricerca è sempre alla base delle nuove idee e in questo eccovi qua, giovani ricercatori che abbiamo selezionato in maniera non facile, ma per fortuna trovando delle elevate competenze nella selezione, e quindi questi posti che ci sono stati assegnati, diciamo, pensiamo, ci vogliamo credere fortemente, sono stati indirizzati nel modo giusto e adesso vedremo anche i risultati. Lasciatemi dire, quindi ringrazio tutti i colleghi, i dottorandi, i nuovi ricercatori che partecipano a questa sfida che notate bene è passata così, ma la Costituzione italiana recentemente è stata modificata su un punto in cui è stato introdotto il concetto di conservazione della biodiversità. Forse abbiamo capito un po' di problemi in questa nostra Unione Europea, in questo nostro Paese, forse stimolati proprio dall'Unione Europea. E allora eccoci qua a parlare, a pensare con progetti che sono indirizzati a vivere in un modo più sostenibile. Un particolare ringraziamento volevo farlo alle 18 aziende, vedo qualcuno che le rappresenta qui in sala, lo ringrazio, che hanno dato la disponibilità a copartecipare a questi progetti, se no non si facevano questi progetti. La logica, che io non condivido completamente, lo dico schiettamente, ma che sia tutto anche finalizzato a una ricaduta, forse non lo capisco perché sono uno scienziato duro e puro, diciamolo così, però ha una sua logica per il nostro Paese. Stiamo lavorando per cambiare il nostro Paese. Questo deve essere chiaro a tutti. Questo deve essere chiaro a tutti, ci tornerò tra un attimo su questo. Però volevo ringraziare fortemente queste aziende che ci hanno dato una mano, che hanno capito il nostro messaggio, la nostra richiesta, il nostro stimolo a partecipare, ancorché pro tempore, a questa iniziativa. Come Dipartimento, lo sapete, noi crediamo in una didattica di qualità, cerchiamo di farla al meglio da anni, abbiamo delle difficoltà sempre come diciamo quantità di studenti, ma questo forse anche perché siamo molto specializzati. Crediamo in una qualità della ricerca, non è un caso siamo un dipartimento di eccellenza, uno dei 4 di questo Ateneo, abbiamo una mentalità istituzionale nel nostro modo di ragionare su queste cose, l'abbiamo sempre avuta e continuiamo ad averla, la vediamo così, quindi cerchiamo anche, cioè voi dovete essere una spinta per continuare a far sì che il nostro Ateneo sia un Ateneo di qualità anche sulla ricerca. E come ha detto il direttore, due cose ancora. Una, vabbè, lasciatemi ringraziare Ilaria Fraudentali perché che è una delle neoricercatrici la quale si è presa il carico veramente pesante di organizzare in pochi giorni questa fantasmagorica follia che è la giornata attuale, che stamattina non funzionava una cosa, tanto per dirne una prima di iniziare, ma è così. Finisco i ringraziamenti e voglio, come dire, inquadrare ancora una volta questa giornata in quello che diceva poc'anzi il direttore, cioè noi come Dipartimento e il nostro Ateneo e inserito in tutta una serie di iniziative che anche queste nascono dall'Unione Europea e a ricadute arrivano all'Italia. Il piano nazionale, il PNRR, non il PNR su cui ci sono stati altri posti di ricercatori proprio finalizzati alla ricerca, ma il piano nazionale di ripresa e resilienza, che è una logica, cioè trasformare la nostra Unione Europea e i singoli Stati membri in un qualcosa che va verso il futuro in un altro modo. Lo accennava il direttore generale prima. Bene, noi come Dipartimento siamo entrati in alcune iniziative del PNRR, poche devo dire purtroppo, come Ateneo, ma in alcune sì, uno il Tecnopole e l'altra è un'iniziativa che è uno dei 5 centri nazionali di eccellenza, il Centro Nazionale per la Biodiversità, che adesso si chiama Natural Biodiversity Future Center. Ci piace? Chiamiamolo Centro Nazionale di Biodiversità e va bene uguale, in cui siamo coinvolti. Io sono riuscito a entrare come Dipartimento di Scienze in questo progetto. È una montagna di denari. Ma quello che voglio dire, al di là della montagna di denari e di chi ci lavorerà, chi è entrato direttamente nei ricercatori che sono diciamo, nel progetto, chi ci entrerà perché sta entrando nei nostri laboratori e quindi lavorerà su queste cose, è una logica del futuro. Dobbiamo ragionare per il futuro. Stiamo creando delle basi nuove di impostazione della nostra ricerca, per esempio, applicata a un modo diverso di condurre e gestire un paese e un'unione di paesi. Un centro nazionale di biodiversità è uno dei 5 centri di eccellenza, guardate, vicino a dei centri che sono estremamente tecnici, molto puntuali. Un centro nazionale che è diviso in 8 spoke, adesso si devono chiamare nodes, hanno cambiato tutti i nomi in questi giorni, ma che cosa vuol dire? Che hanno varie tematiche. Ma Centro Nazionale per la Biodiversità. Guardate, in cui c'è di tutto, ci sono fisici della materia, oceanografi, per fortuna tanti zoologi, botanici, ecologi, forestali, biologi di vario tipo, che tutti quanti lavorano per costruire una logica di nuova idea di come ci si comporta verso l'ambiente. E quindi questi, anche se voi siete ricercatori e dottorandi PON, comunque sia, i fondi sono diversi, ma il tema è sempre lo stesso, il macroscopico tema europeo è sempre lo stesso. La parola green, in maniera iper semplificata, ci dice questo: dobbiamo iniziare tutti quanti, chi con la ricerca di base, chi con la ricerca applicata, e oggi ne vedrete delle belle, a impostare il nostro modo di ragionare, la nostra ricerca anche in questa visione, che dobbiamo pensare che dobbiamo fermare certe situazioni che non stanno andando, dobbiamo porci in un modo diverso nella gestione del nostro paese. La finisco qui perché veramente l'ho fatta lunga, però, allora, stamattina abbiamo ben 12 dottorandi, come diceva il direttore generale, 12 posizioni di dottorato abbiamo avuto, nel pomeriggio avremo 8 ricercatori. Vedrete, i temi sono i più vari. E allora, incominciamo, dov'è Amii? Eccola qua. Incominciamo con una giovane dottoranda, Amii Bellini, che ci parlerà di un tema interessante sui tetti verdi, cioè su come, diciamo, possiamo estendere la funzionalità dell'utilizzo di certune piante, anziché altre, in una lettura di assorbimento della CO2, assorbimento di inquinamento, produzione di ossigeno e quant'altro. Uno dei classici temi green per eccellenza. Prego, Amii. Devi mettere il microfono.
Ok. Good morning, I am Amii Bellini, my tutor is Professor Giulia Caneva, and the title of my PhD project is the enhancement of Mediterranean species to increase the functionality and biodiversity of extensive green roofs. The urban ecosystem is a densely populated space that requires an enormous input of energy and materials. Indeed, cities produce heat, waste, polluted air and water with a negative impact on the biodiversity. While the urbanization is growing in several parts of the world, the planning of more sustainable city is required. And in this context, green roofs are progressively more required as they could provide several advantages. And specifically, they could reduce the negative effect of pollution. They can mitigating both the urban heat island effect and the stormwater runoff by reducing by reducing the volume of the water flowing through the urban waterways. And moreover, they could constitute an important resource to give insulating sound effect and saving energy thanks to their insulating thermal effect. Moreover, the green roofs has also ecological features by improving the quality of urban ecosystem, increasing the biodiversity, as they contribute to produce wildlife habitats and ecological corridors. As the interest in the benefit of building green roof is growing, national and local governments start to introducing various types of incentives and policy to stimulate the popularization of urban green roof in urban areas. Moreover, nowadays, two of the main important topics are the land use issues and needing to install more photovoltaic panels to use solar energy. To avoid the problem of the land use, the installation of photovoltaic panels on the rooftop of the building is more and more frequent at expenses of green roofs. Actually, the combination of these two technologies, so the green roof and the use of solar energy, is possible and could represent an important achievement for the cities in terms of sustainability and ecological transition. According to the Italian norm, there are too many typologies of green roofs. The intensive green roofs that present a thick growing media and where the plant require a regular and frequent maintenance, and the extensive green roof that present a more shallow growing media and where the plants are usually selected among a limited set of species. The extensive green roof, or EGRs, are the subject of my PhD project. While the literature about engineering, hydrology, or energy is plentiful, the literature about the plants is still scarce. In fact, plants usually aren't selected by used ecological method or study the plant characteristic, but they are usually selected among a limited set of species, and literature frequently deals with a case study about sedum belonging to species belonging to the genus Sedum. This is probably related to the fact that the modern extensive green roof were developed in Germany in the 1970s, and in this particular Nordic condition, the species belonging to the Sedum genus have a good adaptability. Starting from Germany, the use of extensive green roof spread in several other countries in North America, Central and Northern Europe, and Asia, and in the last 2 decades, even in the Mediterranean area. In the Mediterranean area, the study of green roof are still scarce. This is probably due to the climate condition in the Mediterranean area that could represent a limiting factor. Actually, the plant biodiversity of this particular biogeographic area is plentiful of species well adapted to tolerate drought stress, intense lightning, and poor and shallow growing media. And those are exactly the characteristics and the features needed for the harsh condition of the Mediterranean urban green roof. At this point, it's clear that there are some knowledge gap. For example, the necessity to study an ecological method for the selection of the species, the lake in the Mediterranean study, and the functionality of the plants. In this framework, this project aims, in line with PON Ricerca e Innovazione and developed in collaboration with the company Bindi Secondo, is therefore to select Mediterranean species with an ecological method to design more functional EGRs, to verify the possibility of increasing the biodiversity and flowering periods of EGRs in Mediterranean area, highlight the potential and the limit of the application of these species, and preserve the regional genotype by using local species. In order to achieve these the aims, first of all, a data set of the most suitable species will be created by using, in one hand, an ecological method previously developed by our laboratory and based on phytosociology, and at the same time, a bibliographic research will be carried out to find the most used species. Starting from this floristic list, we will select the most suitable species to use in two experimental phases. In the first one, the drought tolerance will be studied and characterized by subjecting the species to 3 different irrigation regimes in an experimental green roof, and by studying the response of the plants in terms of survival and development. The second and last experimental phase will be the most innovative one. In fact, only few studies trade this topic, and we will study the functionality of the plants previously selected by studying the photosynthetic activity in summer periods, the thermal insulating effect, and the possibility to increase the entomofauna biodiversity on the green roof. In conclusion, we will expect it to validate the ecological method for the selection of the species, to find out the most suitable species for this application. We expected to find out the higher efficiency of the Mediterranean species than those usually used. And it will be also possible to propose protocols aimed to design more functional EGRs in the Mediterranean area and preserve the local genotypes by increasing the sale of local Mediterranean plants. Thank you for the attention.
Grazie Ani. Diciamo che in ogni comunicazione abbiamo una domanda, poi nella pausa caffè le fate singolarmente. Se c'è una domanda, grazie. Prego, Paolo Visca, puoi fare anche in italiano.
Hai fatto vedere un'immagine che ci sono questi green roof sperimentali.
Sì.
Sì. Dovresti studiare questi diversi reggimenti di irrigazione.
Sì. Allora, abbiamo varie possibilità per l'applicazione di queste sperimentazioni. Una in realtà è molto vicina a noi, infatti in anni precedenti è stato costruito un tetto verde appunto sperimentale proprio nel liceo Keplero, qui vicino in Viale Marconi, e la scuola è a nostra disposizione per poter continuare sperimentazioni sul loro tetto, e il nostro laboratorio tuttora sta effettuando degli studi proprio a livello floristico su questi vasconi. Quindi probabilmente sarà questo il più probabile.
Grazie.
Thank you. Good morning, everyone. My name is Lorenzo Fortini. My tutor is Professor Andrea Di Giulio, and this project is in collaboration with Agri-Consulting Company. My PhD project will focus on the insect Pollinators of Rome for what concerns taxonomic diversity and pollination network as a tool for the management of urban green areas in a large city such as Rome. Rome is one of the largest cities in Europe, and it has presents a lot of urban green areas, which a lot of sizes and purposes. It has an extension of about 1,300 square kilometers, of which 415 square kilometers are represented by natural areas and parks, and 45 square kilometers by urban green. All these areas provide important ecosystem services, working as a reservoir of biodiversity for animals and plants, and contribute to the citizens' well-being. So, ecosystem services are the series of services that natural systems generate to the benefits of man. Insects are involved in many ecosystem services, such as pollination, pest control, nutrient recycling, and maintenance of wildlife species, for example. The main groups that play this role are butterflies, belonging to the group Lepidoptera, well known, wasps and bees from Hymenoptera group, order, many families of beetles, and dipterans in the picture, some overflies. All these insects pollinating not only wild plants, but also ornamental plants and crops. Now, the question is, can big city be biodiversity hotspots for some insect groups? The results to date, the results of the studies are mixed. Some works have shown a negative effect of the urbanization on insect groups, for example, on overflies, wasp, and beetle. In some others have shown no significant effect on bees community. In others, increase of biodiversity for in bees and bumblebees community has emerged. This kind of results must not be taken for granted while talking about an urban environment, and they must be due to the presence in the cities of ornamental or alien plants that are much less common in a more natural environment. In this project, I will focus on bees that are not represented only by honeybees, but by many other species of bees, very often small and solitary bees, with a lot of different ecological niches. I will also study beetles belonging to the family that are known to be involved in the pollination process, such as Cerambicidae, Scarabaeidae, Odemeridae, and Mordellidae, for example. This kind of approach is not usual, talking about pollination process, because usually beetles are not taken in consideration while talking about pollination. It's much more common studying butterflies and bees than beetles and bees. So the sampling will be carried out using an entomological net during sunny days without strong wind in a time slot between 8 and 13 a.m. along a fixed transept 215 meters long, and each transept will be repeated once a month from April to October within 10 green areas within the perimeter delimited by the GRA in yellow. 7 in red are part of Roma Natura Natural Reserves network, and 3 sites within the Appia Antica Regional Park in blue on the maps. All the specimen capture will be stored in 70% alcohol and later prepare an entomological pin to be eventually identified. Pollinators community taxonomy diversity will be investigated through the number of species and relative abundances, and pollination network that these insects establish with flowering plants will also be defined through the compilation of a presence and absence grid by crossing each species of insect captured with the flowering plant species on which it was captured. This way it will be possible to generate statistical indices to obtain information on many aspects of the pollinator community, pollination network. Through the important collaboration with the agri-consulting company, we'll be put in contact with farms near Rome, the city of Rome. This way it will be possible to investigate the effect on pollinators community produced by different management strategy of the green adjacent to cultivated field areas. These areas are very important because represent the corridor through which insects can reach the cultivated field. And to explain the role, this work will focus on to identify the species, but especially identify harmful and beneficial insect species, and indicate the plant species to be preferred to favor pollinators' activities. So, in order to provide guidelines for the management of the greenery adjacent to the crops, and the aim is to reduce the management costs by cutting down some costly and useless, sometimes very dangerous treatment that impact also on beneficial insect species. This way should be possible to increase the quantity and quality of the crops. Or in general, the expected results and impact of the project are to obtain a reliable prediction of the short-time effects on pollinator taxonomy diversity and pollination network posed by the alteration of urban areas, describe and compare those two things of pollinator communities along an urbanization gradient, and modeling the relationships between taxonomy diversity and pollination network with habitat, landscape, and environmental predictors. Also, creation of a synthetic package to be given to the stakeholders, like public administration, for example, and become a reference point for pollinator studies in the city of Rome. Finally, the results of this project will be also useful for urban planning and redevelopment of urban green areas, both from the preliminary planning phases and in redeveloping degraded areas, for example, and also become a reference for public administration involved in the management of the urban green areas. Thank you for your attention. Voi.
Allora, vediamo se c'è una domanda per Lorenzo, prego, il nome e anche Luca. Il nome è Lorenzo Garuti. Grazie alla voce. Perché una curiosità riguardo il cambiamento, perché in quelle fasce perché in quei siti, quei parchi principalmente?
Allora, il discorso della scelta dei siti.
Perdono, scusate. La scelta dei siti. Diciamo, le aree a Roma sono tantissime, quindi c'è anche per dire Villa Panfili, e per anche avere uno standard, quindi quelle sono tutte aree che sono riserve naturali, quindi in teoria ricadono sotto c'è un certo tipo di gestione, quindi la più antica l'ho scelta, almeno per il momento, perché per coprire un angolo, no, è una riserva però regionale. Certo, in realtà poi le caratteristiche sono simili, però quindi diciamo, per avere sul territorio di Roma una stessa distribuzione. Anche, sì, no, regionale. Per il fatto dell'orario, l'attività degli insetti impollinatori ha un picco forse in quell'orario, poi dipende anche tra aprile e ottobre c'è una differenza, chiaramente uno spostamento, in realtà poi c'è anche dopo l'ora di pranzo un picco perché ci sono anche verso le 2, le 3 le ore più calde in realtà non sono quelle indicate. Comunque questi sono i motivi, per l'attività degli insetti soprattutto. Grazie.
Good morning, I am Martina D'Agostino and my tutor is Prof. Thomas Sabelli, and the research project I'm presenting to you today concerns the use and conservation of rare and declining arable species for restoring agroecosystem. Let's first of all introduce the key concept of this research project. The arable species include the set of wild plants present in the agroecosystem that are well adapted to disturbed environment and that evolve with agricultural practices. However, due to the rapid intensification of agriculture after 1950, the arable species undergone a dramatic decline, especially was linked with the traditional agricultural practices. To which must be added the fact that arable species as considered as weeds, and for this reason they are systematically eradicated from traditional agricultural systems. However, currently there are more sustainable farming systems such as organic or low input conventional farming system that show significantly higher species diversity and also an abundance of arable species than the high input conventional farming system. However, even these systems, the arable species that were eradicated, they are no longer able to recognize the former range. So for this reason, the reintroduction of these species is so important to improve their conservation status. And conservation status because the arable species are an important component of the agroecosystem and also may provide ecosystem services. However, the farmers are often reluctant to accept the reintroduction of these arable species in their lands. So, because arable species are considered as noxious by the farmers. So in this context, it's important to understand is if farmers fears of the reduction of productive capacity of the crop due to the competitive relationship with the arable species is grounded in evidence. Because today there are not specific studies about this subject, or when studies the competitive relation between arable species and crops have been faced mainly from an agronomic point of view, how to remove the competition, and not from a conservation point of view, how to promote the ecosystems. The general aim of this research project is to facilitate the use of arable species in the floristic enrichment and also the restoration of degraded environments and as attractors of pollinators in agricultural contexts. First of all, through the identify the sustainable management techniques, and second, through the study the competitive relationship between arable species and crops. The general aim is made up by 4 specific aims. The first of all, to define the state of the art in cytoconservation and reintroduction of arable species, to assess whether crop productivity is affected by the co-occurrence with arable species and crops, and to assess the traits of arable species can be predict the ability of competition of arable species with crops, and also to assess the attractiveness of these species on the pollinators assemblage of the agroecosystems. To achieve the first time, to define the state of the art, I'm reviewing the Graham published literature on competitive relationship, land sharing, and in situ conservation of arable species, but also other plants occurring in the semi-natural habitats. Moreover, I intend to contribute to the debate land sharing versus land sparing. as potential conservation strategy of arable species, and more in general as possible management strategies in agroecosystems. To achieve the second aim, I will set up lab experiment while field experiments are ongoing using Bromus bromodeus, that is endemic of Belgium and extinct in the wild, Bromus grossus, locally extinct in Italy, and the two most famous and iconic arable species, Centaurea chanus and Agrostemma agitago, that in the recent decades have shown a drastic population decline due to the use of non-selective herbicides. The seed of Bromus have been requested from the seed bank of National Botanic Garden of Belgium, while the seed of Centaurea and Agrostemma have been purchased from the Semenostro company of Udine. The seed of Bromus and Centaurea and Agrostemma will be used in 3 different experiments. The first experiment is to identify the competitive interaction between arable species and crops, including germination hibernation among this selective arable in the early stage of development. And to test this relationship, I will be perform multi-species seed germination test with 6 treatments. To achieve the second aim, to assess the real competitive ability of Bromus with crops, I set up at Pavia 20 plots in which, divided into rows, in which Bromus grossus and spelt were randomly sown. The same things is for the experiment 3. That's it, the aim to assess the real competitive ability of Centaurea chanus and Agrostemma agitago with crops. And this part of the research project is in partnership with the seed company Semenostrum of Udine. That is one of the first company in Italy to produce native plant species. At Semenostrum of Udine, we set 56 plots in which Centaurea chanus and Agrostemma agitago were randomly sown in a spelt field. The spelt, yes, this is the video of the plot during the experiment on February. To achieve the third aim, that to assess whatever functional traits of arable species can predict their competitive habitats with crops, I will measure some plant functional traits like plant age, roots, source ratio, and specific leaf area. At the end, for the fourth aim of this research project, I have to identify the role of arable species in attracting pollinators, and for the reason, the sampling of pollinator will be made in 3 daily sessions of the day, where the insect will be captured with entomological nets and then put in the vials, and then the identification of a captured insect will be done in collaboration of the entomological research group of Roma Tre. So thanks to the study that we conducted during these 3 years of PhD, it is possible to provide different expected results, like identify the best practice for introduction of arable species, in particular for the extinct in the wild, the Bromus bromodeus, and also to identify best practices for managing these arable species in the agricultural context, and also for restoring the agroecosystems, but also to identify the strategy to convince the farmers to managing these species. Thanks for the attention.
Allora, grazie Martina, grazie alla collaborazione con l'azienda Telenostro. Adesso una domanda, se c'è tempo per una domanda, prego. Non ce ne sono. Allora faccio io, come mai non si è trovata un'azienda ad esempio qui vicino a Roma?
No, perché
la produzione semi so che è molto limitata.
Sì, sì, infatti è molto limitata e appunto c'è questa azienda Udine con la dottoressa Silvia Solari che penso ci stia anche seguendo in questo momento, quindi la saluto.
Sì,
E... sì, infatti
io non so chi c'è in teleconferenza.
La ringrazio, sì, lei era una delle principali aziende appunto che si occupa della produzione di semi di piante spontanee.
Va bene, grazie.
Grazie a voi.
Tra l'altro siamo...
Good morning, my name is Luca D'Amato and my PhD project is Arbor Urbis, Urban Street Trees and their Ecosystem Service to improve urban quality. Urban street trees are multicultural natural elements for the city and its inhabitants. Medieval cities were very small in size and without trees in the street. In 16th century, Pope Sixtus V planted elms in Rome to refresh pilgrims along the ways of their visit. After these trees becomes more relevant in Italy and in Central Europe from the 19th century, following the urban transformation decided by the Napoleonic administration. The positive aspects about urban street trees are a lot. First, they improve air quality by fixing carbon dioxide and the oxygen emission. They mitigate the effects of pollution and traffic. They mitigate the urban heat island effects. They reduce the surface runoff. And they, of course, provide tangible benefits to citizens like shading and noise reduction. We know that cities in this moment have a significant impact on the climate change, as they are the main emitters of greenhouse gases, producing up to 70% of emission caused by the consumption of fossil fuel. At the same time, cities are affected by the climate change. Therefore, trees allow cities to play a crucial role to addressing the climate change. This project is linked to the 11 goals that is linked to the sustainable cities and communities. And there is an important attention to the city, the green in the city. So greener cities that carrying trees over time and spreading the culture of nature. The PNRR provides 6 million for the new trees by 2024 in metropolitan cities. But in Italy, we needed 227 million by the 2013. So this project is in collaboration with Bindi Secondo. The main purpose of this project is to develop guidelines that will allow to identify the most suitable local autochthonous species. We want also to promote the local floriculture systems and encourage the growth and development of the sector. This project is consistent with the objectives of the National Strategy and Sustainable Development. One of the main purpose is to identify in Latium three species more suitable on an ecological and socio-economical level for development of new green infrastructures. In Latium, we had a wide climatic variability of biomes, 2 biomes, temperate and Mediterranean. And so we choose 5 cities that allow us to make some comparison between the biomes. Street trees are linked also to the ecosystem service because they make, for example, green corridors that connect park and other green areas within the city. They allow the cross-pollination and they allow the animal mobility in the cities. So they represent essential elements of the green transition of cities. In this project, the botanist plays an important role because it's important to maintain a high biodiversity and a low frequency of the species. This is functional to reduce the risk of the spread of pathogens. We know from literature that it's recommended a maximum frequency of 10% for each species, a 20% for species within the same genus, and 30% of species within the same family. Another thing is that these projects will consider the urban aspects of the bioclimate and the soil that become really important elements for the choice of the most suitable tree species. For example, the road wideness, the sidewalk presence, the aeration. All of this is functional to answer some question. Where and which tree have been planted? We know that in Rome, for example, we have 145 species, but we want to understand where and which have been planted the tree. How concern methodology, at the first years, I want to do a bibliographic research to implement the database on the Italian street trees. A selection of the streets where the inventory will be done in the 5 cities. This is in Rome is very important because it's the most difficult city to decide the streets, and set up the information which will be collected on field. The field service will start in this spring, and I will do also in autumn. And the data will be collected in a form that will consider several aspects. First one is a general tree characteristics. After this, the tree biometric data, the phytosanitary state, and the phenological stage. Next years, there will be the collaboration with the garden service, the update of the nomenclature, and the identification of the ecosystemic service. After this, there will be a comparison, a species selection and a comparison between the exotic and the native one. And in final stage, there is a selection of the most suitable species by a genotypic evaluation and agronomic analysis. The expected results, we want to draw up guidelines for the selection of street trees in urban contexts. Another thing that I will do is to disseminate these methods and results to public administration and also to citizens, because it's very important to also to inform the public administration and the citizens in order to promote a green culture. I will encourage the use of native spaces with local genotypes, and of course, at final, there is the selection of the most suitable species for Lazio region. Thanks. Sì.
Avete già un'idea di quali potrebbero essere invece a Roma le piante più interessanti
sì, diciamo che
ancora presto?
Sì, perché noi abbiamo già delle pubblicazioni sull'argomento, quindi abbiamo dei dati di frequenza delle maggiori specie, quindi ovviamente noi andremo a campionare tutte le specie con una frequenza elevata, significativa, ma anche con delle frequenze più basse per avere un'idea. E quindi sì, abbiamo già un'idea. Sicuramente a Roma, per esempio, il platano, abbiamo insomma pinuspine, sono le prime due, però sì, il Quercus ilex.
E per i genotipi come li selezionate?
I genotipi li faremo in collaborazione con l'azienda, diciamo una fase successiva. Genotipi locali, sì, e ci cercherà di fare anche una sperimentazione qualora possibile.
Hi everybody, I'm Silvia Secco. The project I am presenting today concerns the eco-cytotoxicological markers as early warning systems for marine and freshwater ecosystems conservation and aquatic biodiversity sustainability. In this context, I want to introduce the many anthropogenic activities that are leading the transformation of natural biomes into anthromes, resulting in a constant loss of biodiversity. Here, I will focus on aquatic pollution, both marine and freshwater, since they are the most threatened ecosystems. Among all the pollutants, the concentration of two emerging contaminants, plastics and rare earth elements, are increasing dramatically, both in marine and freshwater habitats. As regards the first pollutants, plastics, it is considered an emerging contaminant whose global production has begun in 1950. But only in recent decades has grown exponentially, reaching today millions of tons of plastics produced per year. Furthermore, it is estimated it will increase further in the next years. When we talk about plastics, we are actually referring to different polymers and different dimensions. Undoubtedly, the category mostly investigated is represented by microplastics, which are included both between 5 mm and 1 micrometer. Indeed, this dimensional range allows the ingestion of this material by a wide range of organisms, provoking several effects, both physiological and mechanical. A recent discovered property of microplastics is that they are able to absorb dangerous pollutants from the surrounding environment and act as a vector for them. This is due to the hydrophobic nature of both substances from the larger surface volume ratio of microplastics and because many of them have rough surfaces. As a result, microplastics become contaminant with a higher level of toxicity. The second emerging contaminant on which I want to focus are the rare earth elements. There are 17 chemical elements with a metallic nature. They are represented with by lanthanides, scandium, and yttrium, but I will focus only on gadolinium element. Indeed, gadolinium is the most used element, both in its chelated and ionic chemical structure, for the realization of technological and sanitary devices, such as magnetic resonance imaging. Its use is constantly increasing. In fact, in COVID-19 pandemic phase, several countries have encouraged the technique of magnetic resonance imaging to analyze the spread of lung infection. Moreover, being a metallic material, it is assumed that it can interact with microplastics in aquatic matrix, provoking totally unknown effects on the biota. Today, very few studies have reported assessment of these two emerging contaminants in aquatic matrix, and no one investigated the possible link between microplastics and gadolinium. Consequently, the effects on biota caused by these pollutants are still poorly investigated and understood, and the effects derived by the presence of these pollutants together are completely unknown. From this assumption, the aim of my project is the identification of aquatic biomodels that can act as biological early warning systems to assess the contamination by microplastics and gadolinium both in coastal marine and freshwater habitats and evaluate the possible link between them. Second, evaluate how the biomodels react by the exposure of these pollutants both at individual and sub-individual level. And finally, define guidelines for using these early warning systems as tools to monitor environmental disturbances and for bioremediation projects. To achieve these aims, the project includes both field sampling and applicative experiment in laboratory. As regards field sampling, the assessment of pollutants will be realized to a national scale, including sites in the north, in the center, and in the south Italy, both for marine and freshwater habitats. The biomodels selected as early warning systems are the mollusk Donax trunculus for marine ecosystems and the mollusca Nodontacinia for freshwater ecosystems. The amount of gadolinium and microplastics accumulated in the bivalves will be analyzed with the collaboration of ISPRA Research Institute, while the biological health implication of biomodels will be analyzed with the use of molecular and morphological markers with the collaboration of ARC Study Company. As regards the applicative experiment, the biomodels selected are the Donax trunculus for marine ecosystems and the Cnidarian hydra vulgaris for freshwater ecosystems. As regards these aspects, different concentration of pollutants will be administered to the biomodels and different responses will be analyzed. As regards Donax trunculus, the bioaccumulation activity in mussel and valves will be analyzed and biological health status will be detected, such as vitality, mortality, and oxidative stress. As regards Hydra vulgaris, it is a freshwater organism often used in toxicological tests. In detail, I will focus on its teratogenic endpoints, such as regeneration rate, aberration frequencies, feeding capacity, reactivity of tentacles, and reproduction. The expected results of my project are firstly the assessment of contamination of these pollutants present in the investigated sites and outline the link between these contaminants. The evaluation of the responses obtained from the selected biomodels by the exposure of the detected pollutants in the applicative experiments. And then I would like to propose guidelines to use the selected sentinel species as monitoring tools to verify the status of aquatic habitats and propose them in possible bioremediation projects. Thanks for the attention.
Vediamo se c'è qualche prego, Paolo. Tanto è interessante, no? Che una geologa si interessi anche a tutto, sia stimolata da queste presentazioni più biologiche. Prego, questa è la logica trasversale al nostro documento.
Molto interessante, complimenti a tutti i relatori che hanno parlato adesso. No, volevo chiedere, per quanto riguarda le terre rare, il gadolino, no? Le analisi, dove verranno fatte le analisi chimiche di questo elemento?
Allora, il bioaccumulo di gadolinio verrà analizzato attraverso l'ICP di massa. E allora qui a fisica ci sta appunto un ICP che esatto, è stato installato proprio recentemente e quindi verso settembre farò appunto le analisi.
Il nuovo strumento che abbiamo comprato col progetto del Saluti. Va bene, allora la prossima presentazione è Federica Tomassetti.
Good morning, I am a PhD student Federica Tomassetti, my tutor is Giovanni Antonini and my project is titled Optimization, Prototyping and Validation of a New Device for the Macrobiological Monitoring of Water, named Aqua Control. The water is a primary element for life, but it's also a limited resource, a vehicle for waterborne diseases such as gastroenteritis and foot fever, and it's susceptible to exposure of environmental pollutants such as microplastics and pesticides and heavy metals. The water scarcity is a most problem for the much of the global population, and it's due to different elements such as climate changes, industrial agriculture, and demographic growth, but also a lack of infrastructure for water analysis, and so a poor management of the water resources. An effective monitoring system of water quality is important to control the environmental and microbiological pollutants and make water an easily accessible resource for everybody. The chemical and physical analysis of water is performed through innovative integrated sensors that provide real-time results in
results, and microbiological analysis have serious limitations, such as through long analysis times, impossibility of application on site, and need of skilled staff and specialized laboratories, and consequently high cost. So the optimization of the macrobiological monitoring of water is an important point of the green transition. In this context, the macrobiological survey methods is an innovative, fast and simple colorimetric system for the qualitative and quantitative microbiological analysis. The selective identification of target microorganisms is performed by the use of the specific reagents that change color in according to the redox state of the enzymes involved in the main metabolic pathway of bacteria. The MBS method has been successfully applied for the analysis of drinking water and for detection of the microbial contamination in surface and groundwater samples. The aim of my project is develop the biological, software and hardware components of aqua control device. The device will take care of withdrawn samples in automatic manner, perform the macrobiological analysis on small volumes quickly and directly on site, provide easy to understand and remotely available data, overcoming the limits imposed by the traditional methods. My research will focus on the development of a new reaction media, including a semi-solid matrix for miniaturize the device and perform the analysis on more samples in the same times. Research of new target bacteria, application of the method in biomonitoring for detection of heavy metal and pesticides, and optimization of the analysis for wastewater sampled from the food industries, in particular from the sector of ready-to-eat vegetables. In conclusion, the implementation of this project will be useful to perform a capillary monitoring and an efficient management of the water resources, reduce the risk for human of infection due to pathogenic microorganisms conveyed by water, and keep costs in line for the enterprise that could optimize and reduce the use of the water resources, claiming an eco-friendly brand. Thank you for attention.
Allora, vediamo se ci sono delle domande per Federica. Prego. In questo caso possiamo anche fare un po' di una perché abbiamo tempo.
Come e dove hai scelto di fare diciamo, il prelievo delle acque?
Allora, le acque dovremmo prelevarle in particolar modo, ecco, applicandolo appunto alla produzione di quarta gamma, dovremmo recarci in delle aziende del sud del Lazio, però ovviamente essendo uno degli step praticamente successivi, quasi finali del progetto, diciamo che sarà valutato in modo più concreto in un secondo momento.
Altre domande? Va bene, allora abbiamo concluso ovviamente in anticipo, ma va bene così, questa prima sessione che continuerà dopo la pausa caffè.
Altrettanto la dottoressa Manuela Portaro, l'impiego e lo sviluppo di prodotti impermeabilizzanti usato nell'edilizia per trattenere il radon rilasciato dal suolo e da materiali da costruzione. Vedete che il radon è un materiale radiogenetico e per cui radioattivo, e la ditta è la Mappei. Ecco.
Okay. Hi everyone, I'm Manuela Portaro. I'm a PhD student in earth science, and my project is titled Use and Development of Waterproofing Products in the Construction Industry to Retain Radon Release from Soil and Building Materials. My tutor is Paola Tucimei, and my industrial partner, and I want to say thanks is Mapei, which is a leading company in the field of sealants, adhesives, and chemical products for building. For starter, we know that the sources of indoor pollution are many, and generally usually linked with daily life actions such as chemicals for cleaning products, carbon monoxide and other gases from cooking foods, mold, bacteria, and cigarette smokes, and so on. And it was stressing that the need to limit the consumption for heating has encouraged a better insulation of building envelope with a potential increase in these pollutions, including radon. Radon is a radioactive, radiogenic gas, and its indoor accumulation in an indoor environment can lead to a series of effects to the human body because protracted exposure to significant concentration can lead to a series of problems. Radon is released from building materials and rocky substrates, and it can reach very high concentration in indoor environments, especially if the foundation are not well insulated from the ground. In fact, moreover, the building is generating the pressure to the outside for different pressure temperature, and this can drive radon fluxes inward. So this research work came to characterize the waterproofing material produced by Mapei concerning their ability to retain natural gas radon, and the goal is to improve indoor air quality according to Mission 2 of National Recovery and Resilience Project, which focuses on the green revolution and ecological transition, considering also that a recent legislative decree of 2020 fully modified the previous concentration, previous limit, and has established the maximum radon limit in workplaces and the civil dwellings to 500 to 3 becquerel per cubic meter. And here there is a list of 25 waterproofing material to test, which with some examples such as synthetic waterproofing covering, elastic leaking membrane, resins, bituminous emulsion, and so on. The first step, more in detail, the first step of the project will consist of the determination of diffusion coefficient of radon gas in this waterproofing material. And the test specimen is placed with this innovative experimental setup, and the test specimen is placed between two PVC chambers, where a radon source provides the production of radon in the source chamber, and it changes in the and the change in the concentration of radon in the measured chamber is caused by a radon flow.
Che stavo qua, ho risposto da qua. Non posso
niente microfono da te.
Mo glielo richiedo, sì.
Monica, spegni il microfono. Se li silenzi tutti, dopo non possono più fare domande?
Okay. So the radon source provides the production of radon in the source chamber, and a change in the concentration of radon in the measured chamber is caused by a radon flow through the material. The concentration of radon is measured by a radon detector, in this case NI+. In our laboratory test, we can also vary the thickness of the test specimen. We can also combine different materials together for understanding the performance of the test. The second step is to put this waterproofing material on a removable plasterboard support panels and applied them to the internal wall of an accumulation chamber. Accumulation chamber, and that is a scale model room. And also considering the different natural and forced ventilation. And an accumulation chamber is any closed environment that receives a contribution from a radon source. In this case, the sources are a block of tufo di gallese with high radon exhalation rate and high porosity. The third step of this project is the application of this tested waterproofing material in real cases. We'll monitor the radon both before and after the application of these such waterproofing materials in indoor environment, in soil, and we'll monitor also the intrinsic permeability to soil gases, considering also the different weather and climatic condition, the geology, nature of site, as well as the construction material of the building. So for start, for logistical problem, we start our project from step 2. And for study, we test the super panel made of plasterboard, but without the application of the waterproofing materials on their surface. And the experiment 1 is divided into 5 parts, and in the lower part there is the different configuration of the experimental setup that we use during our laboratory test. So if we pay attention to part 1, without the introduction of panels inside the model room, and part 2 with the panels inside the model room, we can see that there is a great variation in radon concentration, in this case because the plasterboard isn't so for its high porosity, and the plasterboard is it's just a super for the waterproofing material that we will test in future. But we can understand, however, how the introduction of air in the model room, that is the forced ventilation, can reduce the concentration of radon in indoor environment, is efficient to reduce the indoor radon concentration. And in fact, in higher flow rate produced a higher radon decrease. And if we pay attention to part 4 with the maximum flow rate, and compared to part 3 with the minimum flow rate in the model room. And in part 4, the configuration is the same of part 4. Part 5, sorry, is the same of part 4, but with the application of the external cover, and in this way the application of the external cover increase again the concentration of radon. It seems that the application of this external cover balance the forced ventilation in the model room. So, as expected result, the use of an anti-radon material in rare cases with the appropriate ventilation action could reduce considerably the concentration of radon in indoor environments, and consequently upgrading existing buildings and the construction of new ones will be encouraged with better characteristics in terms of air quality and health effects. And in the lower part, there is a summary of my project schedule of 3 years. So, thanks for your attention.
Ci sono domande? Ci sono domande? Allora faccio io. Ho visto che avete proposto anche di farlo poi nel caso di un'abitazione o l'altra, ma nell'esempio che facevi, ma ovviamente era un esempio, facevate vedere costruita ancora con blocchetti di tufo. Sì. Ma pensate di perché che io sappia attualmente non si costruiscono più con blocchetti di tufo, non è più una norma.
In questo caso era, diciamo, per edifici già esistenti.
No, ma quello è chiaro, okay. Però era perché siano paragonabili, nel senso che se tu lo fai con i blocchetti di tufo e quello dopo invece è fatto con materiale non è più facile, ovviamente comunque la situazione...
Ok, lì in quel caso va comunque fatta un'analisi comunque anche del... Oh, scusate, e lì in quel caso va fatta comunque un'analisi della concentrazione del radon nel suolo e come sono anche le fondazioni sono ben isolate, quindi bisogna fare tutta una serie di indagini preliminari per cercare poi di capire quali sono le giuste fasi da attuare poi per la diminuzione della concentrazione del radon e quindi anche...
avere un sistema di costruzione uguale nei due casi, insomma, era soltanto per questo. Va bene. Altre domande? Dove?
Ah, ok.
Quella casa dove sta?
È Caprarola, però era... Sì, ma era solo un esempio per sì, esatto.
Paolo, abbiamo lavorato sugli effetti animali. Benissimo, passiamo al prossimo. Arcangeli.
Grazie.
Parlo di università e cambiamenti climatici come indicatori di tendenze della sostenibilità ambientale. Lo studio dove andare a vedere il Pliocene superiore quando le condizioni ambientali di concentrazione di chiusura erano analoghe a quelle attuali, intorno ai 440 milioni, e per cui diciamo è il primo analogo che abbiamo nel passato geologico, e per cui capire le condizioni ambientali allora era cambiamento è importante. E insieme alla giunta ambiente SRR.
Okay. Good morning, everyone. My name is Pierluca Arcangeli, and I'm a student of University of in Health Science of University of Roma Tre. The topic of my research project is the Palaeobiodiversity and Climate Change as a proxy for environmental sustainability. This is because the geological and paleontological archives are fundamental to evidence for the sustainable and develop a realistic plans for the sustainable and observation of the land, water, and biodiversity. In this perspective, the project of my research is the Palaeobiodiversity and Climate Change in the Mediterranean area between the end of Pliocene and the beginning of the Quaternary through the study of a paleolake. The paleolake is the Aquilan Basin. The Aquilan Basin is an intermontane sedimentary basin and is located in the central Italy and is divided in two large sub-basins, the Aquila Scoppito Basin and the Paganica San Demetrio Castelnuovo Basin. In this project, it will focus of the study the CN1, so the Castelnuovo 1 survey carried in Castelnuovo. This core is characterized by several multidisciplinary studies, for example, paleomagnetic, geochemical, stratigraphical, and so on. And to this study, I will added the high resolution palynological study that will allow to trace the main paleoenvironmental and paleoclimatic changes in a chronostratigraphic context. In fact, the sediments of the Aquilan Basin is a deposit between the upper Piacenzian and the beginning of the Quaternary. The palynological analysis will contribute to detection of the main climatic changes, potentially the mid-Piacenzian warm period, which is considered the modern analog of the current global warming. The first measured glacials at the Gauss-Matuyama transition, and the glacial interglacial alternation with a periodicity of the 40,000 years. Moreover, the palynological height resolution approach will allow the detection and evaluation of the millennial to submillennial variation. But for obtain this data is essential a work in palynological laboratory and the observation with a microscope. So, in laboratory, the samples are subject to a chemical and physical treatment with the aim to extract a polymorph. So the principal chemical steps are hydrofluoridic and hydrofluoridic acid treatment, the sodium hexametaphosphate treatment, and the potassium hydroxide treatment. While the physical step is characterized by the ultrasonic sieving, and after this you build the slide to make analysis with a microscope. The observation of the optical microscope is very important because the palynological analyses are based on the recognition and the counting of the pollen grains under the optical microscope, to then elaborate a palynological diagrams necessary for understanding the paleoenvironmental and paleoclimatic changes. In this slide, you can see an example of the slide for the counting and some pollen, in this case Artemisia, Acer, and Ulmus. So, as I said before, the core CN1 is characterized by several multidisciplinary studies, and these studies are in progress. Thanks to the multi-proxy analysis and pollen, the main aim is reconstruct the climatic environmental history of the upland basin. The paleofloristic and paleoclimatic data obtained by palynology analysis will also to open the development of use related ecosystem resilience and biodiversity conservation for understanding the current climatic change and likely future climatic scenarios. For this reason, the training course will be characterized by a 6 months internship with a partner company, and in my case is Ambienta. Ambienta is specializing in chemical and macrobiological analysis of the main environmental matrix, which will enable me to get closer to the problems of the land management. In addition, I will interact by implementing the skills of laboratories with the new method of the sampling and analysis for the preparation of the mousse and air in order to analyze the different palynomorph and NPP. In this last slide, you can see how my research project will develop in coming 3 years, and the 2 important stages with Ambienta and at Montpellier. The stage at Montpellier will help me to obtain the quantification of the main climatic parameters related to temperature and precipitation in order to reconstruct the paleoenvironmental response to the global climatic change and the new view for understanding the current climatic change. Thank you for your attention.
Grazie. Abbiamo domande? Ascolta, ma alcuni non so, con il gruppo della Magri alla Sapienza?
No, allora, con i pollini abbiamo la collaborazione con l'Università di Firenze. Infatti le analisi di laboratorio e momentaneamente anche le osservazioni le sto facendo presso l'Università di Firenze.
A livello generico o specifico?
In che senso? No, allora, quella slide era in maniera molto generica, quindi avevo fatto semplicemente qualche esempio di polline che posso incontrare, cioè quelle immagini sono già dei polline che ho riscontrato di già all'interno del progetto di ricerca e naturalmente ce ne sono tantissimi altri, quindi si varia diciamo da delle steppe fino a delle vere e proprie foreste naturalmente, e lo scopo essenzialmente è quello di andare a vedere appunto questi cambiamenti, quindi se ci sono dei glaciali e degli interglaciali o comunque, come ho detto anche prima nelle slide, se ci possono essere potenzialmente l'ultimo periodo di riscaldamento, cioè l'ultimo periodo di riscaldamento al passaggio del Pliocene quaternario, questo.
Se c'è tempo con l'altra domanda, la faccio io. Qual è il tasso di sedimentazione che se lo conoscete o vi aspettate?
Allora, diciamo che la carota è molto profonda perché arriva fino a 230 metri.
Ma il tasso di sedimentazione aspettato, cioè qual è la risoluzione temporale dei vostri campioni? Faccio una domanda differente.
Allora, per il momento è ancora tutto da verificare, naturalmente, però diciamo che il periodo è quello appunto segnalato tra Piacenziano e Gelasiano, e momentaneamente i dati diciamo non ci possono dare delle vere e proprie informazioni perché per l'appunto ne sono stati fatti pochi, l'alta risoluzione si farà naturalmente più avanti. E quindi diciamo che ancora non si riesce ben ad inquadrare l'age model. Infatti tutt'oggi siamo appunto in contatto con tutti i collaboratori di ricerca, quindi con il gruppo di ricerca che ci sta lavorando, e per l'appunto si sta discutendo proprio sull'age model, quindi è molto interessante diciamo adesso capire dove cadiamo.
Vabbè, grazie mille. Passiamo al prossimo. Museo diffuso di cultura scientifica nella città di Roma per lo sviluppo di una strategia di vita sostenibile in aree urbane. È fatta con la giornata. I responsabili del progetto sono la professoressa Corrado e la professoressa Civelli.
Good morning, everybody. I'm Lorenzo Garuti, and I will introduce you my PhD project with the title Widespread Science Museums for the Development of a Sustainable Life Strategy in Urban Areas, an application to the city of Rome. This project arises from the necessity to find a solution for a scientific problem that is mainly characterized by a lack of direct experience in earth science in urban context, and in, the scarce use of innovative technology used to enhance geological heritage, and the development of hands-on activities mainly for classic geological topics. For this reason, our main goals are in fact to integrate traditional direct experience during outdoor scientific walks with observation innovative tools, to develop laboratory hands-on activities on more specific earth science topics highlighted in Agenda 2030, and at the end to test the effectiveness of this new strategy of dissemination. In the upper part of the slides, you can see the already existing material proposed by the University of Roma Tre concerning geological sciences in the city of Rome. We have classical geological models, also GeoGarden and different activities. Nevertheless, with this project, we want to introduce and to add with these already existing materials these three main methods: the drone investigation, the virtual reality, and the 3D object creation, in order to design outdoor and indoor geological experience to enhance innovative methodologies for earth science dissemination. Regarding the outdoor scientific walks, we select 6 different itineraries in the city of Rome that you can see here in these tables. They are all declined in a function of the topics on the objectives, but also the method used for the different areas. Starting from the first one, it's about the San Paolo fuori le mura Basilica. That is a very good example about the link between history, architecture, and geology in the city of Rome. And also it helps to give more information about the use and the reuse of stone materials through time. The second and the third one are about two of the most important natural parks in the city of Rome, the Caffarella and the Monte Mario Park, and they will be used to reconstruct the geomorphology and the geology of the Roman countryside. Also to assess very good information about the natural resources and risk, and also the water resource and pollution in those areas, using different methods such as underlined here in the table. The third one is probably the most iconic and the most beautiful because it's about the historical center of the city, moreover the imperial forums, and it will show the role of geology for the development of the city, not only nowadays, but also in ancient times, and also regarding a better look about the natural risk, such as the seismic risk in urban context, to create a geoheritage database, a geotourism database in the historical center, so in the city of Rome. The last one, it's about the Tiber River and its relation and its influence with the city, and also to enhance those problems related to water resources and pollution, but also to better understand the hydrogeological risk and the assessment also and the management of the risk in the city. The last one, we cannot talk about the Roman countryside without speaking about the two most important volcanoes in the Roman area, so the Sabatini and the Colli Albani Hills, to reconstruct the geodynamic evolution of Roman countryside, but also to have a better understanding of the volcanic risk and the stone material associated with these volcanic areas. Regarding, on the other hand, the other part, so the indoor experiences, and so the hands-on and virtual laboratories, we underline four different main fields, we can say. The first one will be to create a virtual rock repository, such here in this example, in this video, you can see one of the typical volcanic materials in the Roman countryside reconstructed on a virtual room that can be consulted by remote by everyone and everywhere. The second one is to visualize geological structures, so from fields to models, because normally in geology we have to see 3D structures that are not so easily without some types of models, or for persons that are not geologists. So with this type of models that are reconstructed with 3D printers, we can better understand those type of structures. The third one is to simulate regional scale processes such as tectonics and erosions that are not easily understandable, also because they are in time scales, but also in depth scales that are not so easily understandable. So with these models in VR on 3D, we can reconstruct them. And the third one, it allows to explore by remote, not easily accessible areas, also to recreate with analogical or virtual models regional scale processes. Okay, here for our expected results, I selected, questo era un video. I selected different, probably the most iconic monuments in the city of Rome, that is the Colosseum, and here on the left side, just to show you the already widely used methods that I selected, the drone, VR, and 3D, but they are more used for touristic and archaeological purposes. So with this project, what we want to do, what we want to add, it's to replace or to add with them earth science purposes. So using the same methods, but for purposes such as the drone, to have a different scale detail, so different view, we can say a zoom of the different stone materials that compose the building, and at the same time to reconstruct in virtual reality room these type of stone materials, and at the end to create 3D models, 3D printings of the substratum, so on the subsurface of the Colosseum. So this project will give a lot of information about and will link all these different earth science branches, also giving a help and support to different SDGs contained in the Agenda 2030, such as the sixth one that I selected, and moreover about the goal 11, that is about sustainable cities and community, because the main goal of our project will be to build a multi-approach methodology, not only for the city of Rome, but also for the citizens of Rome, that could be exported in other urban and geological contexts. Before to finish, I just want to show you my timeline chart, where you can see that all the different steps and all the different collaboration, starting from the beginning to the end of my project. Thanks a lot for the attention. If you have questions, I'll be glad to answer to your questions.
Sul come? Sì.
Che tipo di aspetti stai pensando
Allora, San Paolo rispetto alle altre poi è l'unica, diciamo, che è appunto puramente indoor, perché comunque diciamo è un indoor-outdoor sostanzialmente, perché appunto rispetto alle altre in cui appunto sicuramente l'uso del drone sarà un uso prevalente come tipo di metodologia, lì non sarà possibile molto probabilmente, pertanto sarà una ricostruzione più che altro del tipo di rocce appunto presenti all'interno, ma legato non soltanto alla roccia stessa, ma anche alla storia della basilica legata a quel determinato tipo di roccia. E quindi ricostruire queste appunto in realtà virtuale con modelli 3D. Sì, più o meno il focus sarà quello, però sì, sicuramente sarà relativo al tipo di rocce ornamentali utilizzate, quindi i processi geologici che hanno portato alla formazione delle stesse e quindi creare, diciamo, dei volumi consultabili appunto online. Esatto, infatti anche comunque parlare dell'area, il focus principale, diciamo, del museo diffuso è questo, che il museo stesso appunto è ospitato dalla città, quindi la città stessa diventa anche il museo, e quindi sicuramente parlare del fatto del Tevere, la posizione in cui si trova, quindi storicamente cosa appunto è successo alla basilica in sé, anche come luogo, non soltanto all'interno della basilica. Certo, sì, sì, sì. Ok. No, sicuramente c'è ancora tanto da scoprire riguardo, quindi senza dubbio. Grazie a lei. Sì.
Parli di museo diffuso, sai che a Roma dei musei scientifici e c'è un progetto Città della Scienza. Attualmente ci sono sul laterale. Volevo sapere se aspetti anche delle commissioni su questo progetto per la città.
Beh, sicuramente, perché come appunto mostravo prima, se, vabbè, ritorno nella slide se vuole, appunto esiste già del materiale sicuramente, anche proposto dall'università stessa. Diciamo, l'innovazione che vorremmo portare con questo progetto è il fatto appunto di utilizzare dei metodi, quelli che appunto vengono definiti le new technologies, che quindi certo sicuramente ci sia un link, un interscambio con diversi enti, ma anche con diversi musei, sì, sicuramente, integrare questo database, appunto il fatto, diciamo, renderlo sia virtuale che fisico, sarà questo sicuramente il valore aggiunto, che il virtuale potrà essere utilizzato anche da diversi siti, quindi sì.
Good morning, everybody. I am Imen Boujmil, PhD student in Condensed Matter Physics, Nanoscience and Complex Systems. And in my PhD project, we want to answer this question. What are the effects of magnetic ionic liquids on cellular biomolecules under the action of external magnetic fields? But why are we interested in answering these questions? Because the magnetic ionic liquids could be used in interesting applications useful in biomedicine and pharmacology, such as isolation of nucleic acids, isolation of proteins, drug delivery, and also in nanofluidics and in diagnostic, for example, to increase the elastic gap between tumor cells and healthy cells. But what are magnetic ionic liquids? Magnetic ionic liquids are organic salts composed of organic cation and inorganic or organic anion. They have paramagnetic properties and they are liquid around the room temperature. Ionic liquids are called green solvents because they have a very low vapor pressure that limits the release of the ionic liquids into the atmosphere. Furthermore, the magnetic ionic liquids are reactive to an external magnetic field, changing their solvation properties, allowing the new green approaches for bioprocessing of biomolecules. My project is organized in 3 work packages. In the first work package, I will study the degree of toxicity or cytotoxicity of magnetic ionic liquids and on cells. In the second one, I study the effects of magnetic ionic liquids on biomembrane models, such as liposome, bilayer of lipid bilayers. And in the third one, I will study the effects of magnetic ionic liquids on cells under the action of an external magnetic field. But this is our goal. But how can we achieve this goal? Different investigation approach will be used, including atomic force microscopy, neutron reflectometry, molecular dynamic simulation, and high resolution imaging techniques. Okay. The projects include 12 months period abroad, 6 months at University College of Dublin, and 6 months at Cyro 60 company, based also in Dublin. The part of the project in the company will focus on optimization of soft X-ray microscopy of the company. And as we see in the figure, the resolution of a soft X-ray microscope is much higher than the resolution of fluorescence microscope, and it's so useful for our project. And that's all. Thank you for your attention.
Una domanda, una curiosità.
Sì.
Dal punto di vista chimico, che tipi di ioni andrete a studiare? Sono a base di midazolo?
Esatto, quelli esattamente. Allora, mi rimetto qui. E praticamente c'è un vasto, cioè la letteratura è vasta, in particolare sui liquidi ionici, ma non i liquidi ionici magnetici. Ok, quello che vogliamo fare noi innanzitutto appunto è studiare perché i liquidi ionici allora, vengono utilizzati adesso soprattutto le nanoparticelle magnetiche, ok? Sempre per le applicazioni che vediamo, che vi ho fatto vedere prima per quanto riguarda i liquidi ionici magnetici. Quindi noi andremo a studiare, a confrontare queste due tipologie, i liquidi ionici magnetici con le nanoparticelle magnetiche, perché solitamente vengono anche utilizzate insieme. Quindi noi vogliamo vedere appunto quale di queste due diciamo di questi due elementi, ok, le nanoparticelle e i liquidi ionici magnetici sono più efficienti nelle applicazioni, nelle bionanotecnologie e quindi sì, maggiormente erano utilizzati a base di midazolio. Ok.
Altre domande? Non ho altre domande? Se non ci sono, grazie.
A voi.
Good morning to everybody. I'm Mariagrazia Leccisi. I'm presenting you the project about the study and application of algorithms for the accurate management of sensors for precise agriculture. Agriculture is an ancient human activity to produce food for human life. Now we think that it is at an epochal turning point. In fact, a classical approach, called also intensive approach, increases production in order to satisfy the need for large quantities of product as cheaply as possible, also authorizing practices such as the intensive pesticides or fertilizers that are not always compatible with a product of quality. The diametrically opposed approach is an organic approach that guarantees the quality of the product by several management protocols. Obviously, this happens at the expense of inevitably higher prices, higher costs, and also low production. There is a new approach that has the ambition of ensuring quality in intensive production by severely limiting the use of chemicals. The new paradigm can be described as only if needed, when needed, and where needed. This paradigm requires timely monitoring of the agricultural field in space and in time, allowing the individual plants to be checked, analyzed individually in order to immediately intervene in case of problem. For example, a parasite attack could destroy a plantation and entire crop very quickly. So it's important to intervene in a few time. Also, the use of sensors to monitor the state of health of an environment is a great topic in agriculture. In fact, is a great topic in agriculture. In fact, a particular condition of, as example, of humidity or temperature could create problems to the leaves or favor some attack from parasites. And by acting promptly and punctually, we have the great opportunity to act only on a small number of plants, providing them with what they need in that moment, preventing possible pathologies and avoiding that the waste also of water and also the damage to the environment. So we can think of about a platform of mobile and fixed sensors placed on drones that will have the task of active surveillance of the field. Also through the use of special actuators, it will be able to implement some actions as provide for fertilizers or waters if needed. And this is technically possible thanks to the availability of the IoT technologies or Internet of Things technologies. And in the figure shows an example of this platform, a conceptual example of this platform, where there is a central unit of artificial intelligence that collects data from the sensor, from the fixed and mobile sensors, and collects this data, analyzes this data, and is able to take a decision as soon as possible in case of problem. Eventually, it can be able also to provide for communicating to other terrestrial drones, for provide for pesticides or waters, or also can warn the farmer if a human intervention is needed. A central point of this project is the analysis, the study, the implementation and the application of methods that allow to accurately evaluate the data coming from all the sensors. They are heterogeneous data. And because we can have data from, for example, mobile sensors that are cameras or a webcam, or also LiDAR systems or GPS, and also from fixed sensors as humidity or temperature or quality of air. Okay, the main problems in this project can be divided into two types. The recognition of plant problems that involved particularly both fixed and mobile sensors. As example, we can think of take a picture of the leaves of each plant, comparing it with some data on a database, and merging data with as example, data from the sensor of humidity or temperature, because in particular condition we can extract a possible problem to a plant. On the other side, we have the movement of drone. In this case, are considered particularly the mobile sensors as a camera or a LiDAR, particularly LiDAR sensors, in order to make the drone go straight without destroying the plant. And through artificial intelligence and data fusion, we can try to resolve these problems using, as example, neural networks or algorithm of clustering and so on, and collecting data of heterogeneous type in order to have some information. So the purpose of this project is surely to improve and optimize the operation of those who manage a farm, so the farmer, but also to bring a health and economical benefit, not only to the company and to the farmer, but also to the environment, avoiding the spread of water or the excessive use of pesticides or also fertilizers, giving also a product of measured quality, respect an intensive cultivation. And we hope it has a world record in implementing algorithms for the early recognition of problems, particularly in agriculture, but also in aquaculture and in other fields. Thank you.
Ci sono domande? Prego. Allora, siccome queste cose si fanno già in Italia, usare i biosensori in agricoltura, domandavo, ma ad esempio, esatto, lo dico io sul entomologo, ma se c'è l'infestazione di un insetto fitofago X, come fai a valutare la quantità del danno, della necessità di intervento, eccetera, solo da remoto? Hai bisogno comunque di un lavoro di campo che si interfaccia con queste cose?
Allora, diciamo, l'idea non è quella di, diciamo, sovrastare il contadino o comunque colui che gestisce il campo, è quello di aiutarlo nella gestione. Quindi diciamo sicuramente c'è in alcuni casi necessità di un intervento umano, infatti diciamo l'idea è quella di una piattaforma che diciamo dia delle indicazioni anche al contadino per decidere se c'è effettivamente un intervento. Quindi l'idea è quella di, ad esempio in questo caso di un'infestazione, attraverso una foto o comunque i vari sensori viene diciamo evidenziata una possibile infestazione, allora se non è una cosa diciamo risolvibile in modo semplice si avverte, sto semplificando insomma, e poi si avverte il contadino che poi si occuperà di decidere cosa fare. Si può pensare anche di implementarlo diciamo una piattaforma, quindi un'applicazione che magari invia anche un drone terrestre o una persona a fornire quello che è necessario in quel momento per evitare che magari l'infestazione vada avanti. Quindi ecco, è di supporto al contadino, dove è possibile si può intervenire in autonomia, per esempio se manca l'acqua, se il terreno è asciutto si può intervenire in autonomia. In altri casi sicuramente è importante avvertire tempestivamente il contadino che magari in grandi campi quel problema specifico avviene in un piccolo spazio, magari neanche se ne riesce ad accorgere subito.
Una domanda, perché allora, il comparto dell'agricoltura in Italia è piuttosto avanti con l'età, quindi c'è un problema nel senso che utilizzano molto più spesso l'agricoltura tradizionale. Come fai per innovare questo comparto? Perché ovviamente tendono ad affidarsi alle strutture che già conoscono, che fanno fatica ad innovare rispetto ovviamente a una protezione.
Vabbè, io posso pensare che magari si possa cominciare a proporre, diciamo, alcune tecnologie che sicuramente possono essere utili e poi magari piano piano, diciamo, implementare dei servizi sempre più complessi e ovviamente anche Una cosa che non ho specificato è che sicuramente c'è la necessità di utilizzare agronomi, anche altri contadini, altre figure professionali per capire bene quello che c'è, diciamo, da fare, come anche analizzare questi dati e come studiarli. Quindi, diciamo, piano piano si può pensare di estendere, di magari partire da un piccolo monitoraggio e poi estenderlo ovviamente anche in un progetto più grande, ecco, anche per i piccoli agricoltori.
Rispetto alle culture che voi analizzare, cioè nel senso sono molto diverse a livello di sviluppo di patogeni, anche culturali. Voi che tipologia di culture volete sviluppare questo modello?
Allora, grazie alla domanda, è interessante perché alcune cose non le ho specificate per velocizzare, insomma, però diciamo il progetto parte già, il drone è esistente, è un drone anfibio e diciamo si sta lavorando su un vigneto di aziende agricole umbre, quindi diciamo partiamo, visto che ovviamente sono tantissime le patologie problematiche, partiamo da un caso specifico che è quello della vite. Quindi siamo in accordo con 2 aziende viticole umbre che appunto l'idea è quella di far spostare questo drone già funzionante con i sensori, però ecco, cominciare da questo per poi eventualmente estendere anche ad altre problematiche.
Grazie. Ci sono altre domande?
Interessante. Io volevo chiederti, ma tu hai parlato di diciamo risposte, cioè dare anche pesticidi per rispondere a una possibile infezione, ma ci sono già dei sensori, per curiosità, ci sono già dei sensori che riescono a scindere varie infezioni, vari patogeni, hanno dei sensori per, che ne so, metabolismo, comprende il metabolismo secondario, cioè come fanno a scindere che la pianta, a parte le foto?
Sì.
Si fa la foto e si vede la malattia. Cioè, ci sono dei sensori specifici che riescono a capire un parametro di patologia caratteristico.
È la stessa domanda.
Allora, diciamo che sensori specifici che io sappia non ci stanno. Ci stanno?
No, perché è una cosa che avevo, cioè, era un progetto che c'era venuto in mente di sviluppare in realtà, quindi possiamo...
Vabbè, si può pensare, perché allora, il problema di base di questi sistemi non è di per sé solo trovare l'algoritmo ed elaborare i dati, ma avere le informazioni, sia il tipo di informazioni che la quantità di informazioni giuste per avere effettivamente una detection adatta. Quindi si tratta di fare foto, ma non soltanto, prendere, infatti questi algoritmi dovrebbero anche fare questo, evidenziare, discernere varie patologie sulla base sia del riconoscimento di immagini, quindi tramite foto, ma anche webcam, ma anche questo è complesso perché si parla comunque di camere particolari, multispettrali, quindi non è il cellulare per intenderci, è attraverso tutti questi dati e un'elaborazione specifica di queste immagini e di altri dati che stiamo analizzando, proprio cercare il più possibile di differenziare, quello sarebbe l'optimus, differenziare le patologie. Quello sarebbe l'optimus.
Grazie, va bene. Allora andiamo al collegamento con la dottoranda Bindi Secondo. Se puoi condividere lo schermo.
Hello and good day to everybody. I am Ayda Ghary Haghighat, who was accepted in the 37th cycle in Roma Tre University for PhD. And my PhD thesis is about recycling and 3D printing of rare earth permanent magnets. My tutors are Dr. Gaspare Barbaro and Professor Fabio Bruni. This PhD will be done in Roma Tre University with the collaboration of NM2 Lab, both in Roma and Genoa, as well as the GEME Technologies in Torino. At first, I want to give you a very brief definition of permanent magnets. Permanent magnets are the materials which are permanently magnetized. You can see the hysteresis curve in this picture, in which there are some points which are very important, and we can measure the magnetic properties of the permanent magnets using them. These points include remanence and coercivity. You can see a rectangular in this loop, and the bigger the rectangular means that the higher magnetic field we can obtain when we use the magnet. Magnets are classified into two main groups: sintered magnets, which are produced by the sintering process, which means that we use heat during the making process, and also bonded magnets, which are produced from magnetic particles dispersed in a proper polymer. Both of these groups have their advantages and disadvantages. For example, sintered magnets have the highest output, and also we can use them in higher temperatures, but they are very expensive and large losses occur during processing. The other disadvantage of sintered magnets is that we cannot make them in any flavored shapes, but bonded magnets can be produced in any complex shape, and it is the most important advantage of them. Also, they have higher electrical and oxidation resistivity, and minimal or no secondary operations are needed during their making processes. The disadvantages of them can be the lower density and the lower magnetic properties compared to sintered ones, which are due to using polymers in their structure. As shown in this slide, magnets are classified to anisotropic, which means oriented by using a magnetic field during their making process, and also isotropic, which means randomly oriented. As can be guessed, the anisotropic ones have better magnetic properties. Another thing that we can see in this picture is that in sintered magnets, there are just grain boundaries, but in bonded magnets, we can see magnetic particles dispersed into a polymer. In this slide, I just want to show very brief important usages of permanent magnets in our lives. For example, they're used in hybrid cars, wind turbines, and solar cell motors, which are essential to obtain sustainable, environmentally friendly, and green energy resources. Also for hard disk drives that are very important in our digital era, as well as medical uses and so on. In this slide, you can see the performances of different kinds of permanent magnets. As you can observe, the highest performance is for neodymium iron boron magnets, especially from 1985, but they are the most critical ones because they contain rare earth elements, and you can see that they are in the highest level of supply risk. The reason is that the majority of rare earth mines are located in China, so they can manage the price. And you can see that there are fluctuations in the price from 2020 up to now, so it can be related to some geopolitical problems. Also, the demand for rare earth metals became more and more because of the need to move to sustainable energy resources. So there are some actions that we can do as solutions to this problem. The first one is improving the performance of existing materials. For example, exchanging coupled hard soft materials. In this case, the experimental results are far from theoretical predictions. The second solution is developing new hard magnetic materials using non-critical, easily accessible, and reusable elements, which is very challenging. The third one, and also the most important one, is recycling and reuse of end-of-life permanent magnets, which can be done by two processes. First one is chemical extraction of pure rare earth elements in the form of oxides, and the second one is magnet-to-magnet process, which is selected by us to be done during my PhD. In this case, we managed to destruct some sintered end-of-life magnets coming from motors, and then making some filaments from them by adding some materials and again using them as magnets. But unfortunately, despite the criticality of rare earths, just 1% of them are recycled up to now. Concerning my PhD project, this work will be done in four main steps. The first one is thermal treatment for a safe manipulation of the magnets. Step 2 will be the developing of a novel and optimized milling process using hydrogen decryptation and ball milling, so we can obtain particles in micrometer size and they should preserve their original magnetic performances. The third step is dedicated to fabrication of 3D printing filaments consisting of homogeneous dispersion of magnetic powders in a fusible and recyclable polymer. And lastly, we aim to make new bonded permanent magnets. This step will be done by the involvement of GEMA technologies to perform micromagnetic simulations. So we want to use a customized 3D printer by which we can apply a magnetic field during the printing process. This is also a process of bonded magnet reuse, which you can see inside this cycle. However, it is not going to be done during my PhD. And at last, I want to thank you very much for your attention, and if there's any question, I'll be glad to answer it.
Thank you. Any question? No question? No question.
Okay. Okay, thank you.
Thank you.
Azioni dei progetti di 8 ricercatori di piano, in questo caso in collaborazione con tutta una serie di aziende che hanno dato la sua comunità. La prima relazione è di Alessandra Riccieri sull'Università di Conservazione di Bindi Second in medici italiani, azienda ospitante per la consulting. Prego Alessandra.
Funziona? Sì, funziona. Buon pomeriggio a tutti, vediamo se... Sì, ok. Okay, so today I'm going to introduce you the scientific background behind the project I'm going to develop in the next years, in which I'm going to select some species of insect, in particular of endemic, Italian endemic insects, and I'm going to analyze their genetic variability, and eventually to propose some conservation strategies to possibly avoid their potential extinction. So probably most of you are already familiar with the concept of biodiversity, but just to remind you that with the term biodiversity, we mean the total variety of life that is present on Earth. And we can study biodiversity at different levels, so at an ecosystem level, species level, and genetic level. Lately, we hear talking about biodiversity in many different contexts, and these days is a word really used. And as Professor Bologna anticipated this morning, the great news of this period is that biodiversity entered our Constitution. And not only the word biodiversity entered our constitution, but it is associated to the word protecting. So this means that there is more awareness about the importance of biodiversity, and that the protection of biodiversity is not only a prerogative of scientists and biologists, but of the whole community. This fact is particularly important for our country, so for Italy, because Italy is one of the European countries with the highest level of biodiversity, with the highest amount of biodiversity, both in terms of plants and in terms of animals. Of course, we have to consider also geographic areas near our boundaries, which are part of the geographic Italian region. If we count only the species of animals that are present in our country, we can estimate that we have about 60,000 species of animals. Italy is also the first country to produce, that produced in the past a checklist of its own fauna. This checklist is being currently updated, but if we consider the checklist published in the 1995, we can see that were listed about 58,000 species, most of which belong to arthropods. And it might not be surprising, but most of these species were insect species. And within the insects, again, the largest order is that of beetles, so Coleoptera. So Italy is not important also only for the high number of species present in its area, but also because it presents a very high percentage of endemic species. So an endemic species is a species. It means that the species is present only in our country. So it's restricted to Italian region. According to the checklist of the Italian fauna I showed you before, it was estimated that about 10% of species in that list are endemic. But with the current updates, we can say that there are more than 10% of species endemic in Italy, and they belong to all the taxonomic group. So, which are the characteristics of an endemic species? First of all, endemic species must have a localized range. This means that their range is not so widespread. Endemic species have also a high specialization in their niche. Sometimes, in most of the cases, I will say, they show a low population size, so a low number of individuals in their populations, and in many cases also reduced genetic diversity. So this fact is really important because genetic diversity represents the evolutionary potential of a species. What does it mean? It means that the evolutionary potential is the ability of a species to adapt to environmental changes. Environmental changes are something that happen naturally in nature, but usually natural environmental changes are leave the time to the species to adapt if they have an adequate genetic diversity. So the problem is that when the environmental changes are caused by humans, so are from an anthropic origin, like this listed here, they are quite quick, fast, sudden changes, not leaving the species the time to adapt, both if they do not have, both if they have a high genetic variability, but mostly if their genetic variability is already low. So they might be assimilated more to catastrophic events, not to the natural environmental changes. So which are the main factors that influence the genetic diversity, so that concur to maintain an adequate level of the genetic diversity within a species or within their populations? The first one, of course, is the number of mutations that anyway take a long time to settle within a population, so I'm not considering them. But two very important factors that help maintaining the genetic diversity within a species are the number of individuals and the gene flow. So it has been demonstrated that small populations, so that means population with a low number of individuals, have a very high rate of loss of genetic diversity if compared to large population, as you can see in this graph, of course, through time. Whereas the gene flow means the exchange of individuals among populations, between two populations, like in this example. And this helps the homogenization somehow of the genetic variability between the population, because each individual that is exchanged between populations carry with him, of course, its own genetic, its own genotype. And so if two populations, for some reason, find themselves isolated, for example, geographically isolated, this isolation can be overcome thanks to the migration of individuals between populations. So if we now consider again the characteristic that I described you about the endemic species, we can say that there are different kinds of localized range. There are endemic species, like this example, that have a very localized range that I would say almost puntiform. That means that in these cases, the whole populations correspond to the whole species. So in this case, of course, it's not, we cannot talk about the gene flow between populations, but the gene flow will be among individuals of the same populations. And so the number of individuals in that population is very important to maintain the genetic variability of the species. But also, if we consider species, endemic species that might have a wider distribution, it might happen that actually the populations are distant and isolated, and that for some reason the gene flow cannot be, is not present because maybe individuals are not able to move around the populations. And so in this case, we will have very fragmented populations and population with their own genetic identity, different from each other. And also in this case, the number of individuals of each population will contribute to the genetic variability of the population. So if we consider also the number of individuals of the population, so the size of the population, and we consider the fact that these two are two of the parameters used by the IUCN, which is the International Union for Conservation of Nature, that list the species that might have a high extinction risk. So these two are two of the parameters used to select the species in these red lists. We can for sure say that endemic species are at high extinction risk, and that they should be considered as a priority in conservation strategies. So according to this background, the objective of my project will be those to select some species of Italian endemic species, of course of insects, which, as I showed you before, they represent the most of the variability of the biodiversity in Italy, and are also very understudied. And I will study their phylogenetic relationships of the species selected with other congeneric species, for example, or other related species, to, for example, evidence the presence of of cryptic species or other interesting factors. Then I will focus on the species itself, and I will study the genetic variability within the species to evaluate the potential, the evolutionary potential of the species, the presence or the absence of the gene flow among the population of the species selected, and also in the end, if needed, I will try to propose some conservation plans to avoid their potential extinction. So to give you just an example of what I'm currently working on, I will show you some example of species selected. This species, Meloe apenninicus, is a species of beetles, in particular of the family Meloidae, blister beetles, which is of course endemic of Italy. And as you can see here, this is its distribution. And you can see that populations are quite fragmented. And this is also due to the fact that this species is mostly distributed in mountain ranges, so it can be found between certain specific altitudes. So in a wider, broader work we are doing about the whole genus Meloe, including 2 individuals of this species, we found that these species are actually not monophyletic, as we expected, being belonging to the same species. And so, and in particular, we have here one individual coming from Sicily and another one from Abruzzo. And so we hypothesize that these might be two cryptic species. What does it mean? It means that these two individuals are morphologically identical, so they cannot be discriminated as two different species, looking them at the microscope anyway, morphologically, but they genetically are completely different. So the next step of this work will be to study the genetic variability of as many populations as possible to confirm eventually this result. And if this result will be confirmed, this will mean that we have a new species of insect in Italy, so another one to add to the list we saw before. Another example that is completely different compared to the previous one regards a genus of the family Edemeridae, the genus Stenostoma, which includes 4 species, 2 of which are endemic of Italy. In particular, Stenostoma melitense is endemic to South Sicily and Malta, whereas Stenostoma costirense is exclusively present on Pantelleria, in the Pantelleria Island. So also here we are conducting a phylogenetic study about the whole genus Stenostoma, and we found out a thing that is completely different from the previous one. That is that these two species, besides being completely different, as you can see from morphological aspects, they share the same genetic properties. So they seems to be completely identical from a genetic perspective. We are trying to investigate which are the reasons behind this very strong morphological differentiation, and we believe that we are probably in front of the so-called incipient speciation, so that this speciation event is really recent. And here I finished, and thank you for your attention. Oh, bene.
Ok. Grazie. Prossima. Non lo leggo perché è eccessivamente lungo e guardo il colpevole, ma in sintesi.
Come no? Sì.
Specie naturali, diciamo, piante di interesse agrario e lo sviluppo di agricoltura integrata organica per conservare la biodiversità degli ecosistemi.
Buon pomeriggio a tutti. Today I talk you about my RTDA project, Biostimulants and Natural Defense Enhancers of Agri-Food Plants for the Development of Integrated and Organic Agriculture in order to preserve the ecosystem and biodiversity. Plants are sessile organisms. For this reason, they are vulnerable to environmental changes. Many factors are involved in plant responses to environmental stress. For example, plant genotype, developmental condition, the intensity and duration of the stimulus perceived, as well as the synergic effect of all these stimulus taken together. As a result, plants respond through a multitude of mechanisms, and the lack of an adequate responses could result in plant death. This characteristic make all plants extremely vulnerable to environmental changes, and this vulnerability is even more evident in crop species due to domestication processes and the subsequent genetic improvement, both resulting in a lower biodiversity. Crop domestication is the process of artificially selecting plants to increase their suitability to human requirement, for example, test, yield, and cultivation practices. Increasing evidence underline how crop domestication profoundly altered the interaction among plants and herbivores or their natural enemies. In general, domestication causes reduced resistance against pests and increased susceptibility to environmental abiotic stresses, making crops dependent on human care. The interaction of plants with environment play a fundamental role, especially in consideration of the recent and sudden climate changes, which have a negative impact in the biosphere, both in naturally and agronomical environment. So, for this reason, global food production is put at risk by the recent and sudden climate changes. The three greenhouse gases, which are carbon dioxide, nitric dioxide, and methane, have been steadily increased as reported by the WMO Previsional Report of the State of the Global Climate, with a consequence, so dangerous increment in temperature. It has been reported that a quarter of world food production could be lost by 2050 due to the soil degradation, water scarcity, and climate changes, with dangerous consequences for food security. From the world population prospect, also, it has been shown that population will rapidly increase, reaching about 10 billion by 2050 and 11 billion by 2100, compared to the 8 billion of people present today in the world. The challenge of the coming years is to create a sustainable food future, producing a good quality food in sufficient quantity, without using more land, so preventing deforestation, and without increase the three greenhouse emissions. In this regard, the agricultural practices contribute about 14% to the gas emission, the three greenhouse emission, making this sector as a major contributor to the climate warming. In this serious situation, a possible solution could be to promote a sustainable agriculture and a circular economy. The circular economy represents a promising strategy for supporting sustainable, restorative, and regenerative agriculture, and the circular agriculture focused on using minimal amount of external inputs, regenerating soil, and minimizing the impact of the agricultural practices on the environment. In the circular economy, waste can useful become a research. One of the main problem of the intensive agriculture is the huge amount of waste it produces. A lot of this waste is biomass. Biomass could become a research potentially useful for the obtainment of byproducts with high bioactive properties. So it's important to reach the zero waste circular bioeconomy goals in the next few years, which can be summarized as sustainable utilization of food waste and resource recovery, bioconversion of food waste through low-cost technology, and reduction of emission and use of green technology for crop. The aim of the project is to develop new products based on microorganisms, biostimulants, and physioactivators that act as a regulator of physiological mechanisms and natural defense response enhancer by improving the plant growth, development, and stress responses in crop species, also considering the possibility to use waste from the agri-food chain as a source of bioactive compounds. For this purpose, specific treatment can be used as a tool to stimulate plant defenses and increase the content of bioactive compound with protective function and nutraceutical properties. One of the main goals of this project, is to explore the possibility of use the waste from the agri-food chain as a source of bioactive compound of the secondary metabolism, which have antioxidant, antibacterial, and nutraceutical properties. Crop plants will be treated with these obtained bioactive products, which are microorganisms, physioactivators, and biostimulants. And then phenotypic, biochemical, and physiological analysis will be carried out to analyze the plant's fitness, plant state, also as a phenotype or as stress responses. The specific analysis carried out will be the analysis of the production of biomass, the relative water content, the photosynthetic parameters, the oxidative stress, defense response such as the modulation of the stomatal pore, and the long-distance signaling induced by stress mediated by reactive oxygen species and calcium. Sorry, this the extract will be carried out in collaboration with Agriadeus, which is the partner company in this project. One of the first research line I'm working on now is to find and test natural insecticide from agricultural waste for the sustainable control of phytogaphous insects in horticultural crops. For this study, the target plants will be the belonging to the Brassicaceae family, and the target insect belonging to the Pieris family. On the other hand, Solanaceae waste represent the search of the bioactive compound with insecticide properties. We have carried out two kinds of tests, the repellency binary choice test and the repellency no choice test. Then we also analyzed the effect of this treatment on plant phenotype. But the analyses are now still in preliminary phase, and the further analysis will be carried out to find different bioactive products from agri-food chain to evaluate their effectiveness. In conclusion, improving the availability of low-cost and low environmental impact treatment will allow to increase the competitiveness and export capacity of the agronomical sector company while preserving biodiversity and ecosystem. Thanks for your attention.
Ho capito se il progetto sarà quindi in Italia o sarà fatto del tutto con la clima, quindi
no, quello diciamo era una grande introduzione per dire in realtà che bisogna fare qualcosa per risolvere tutti i problemi che si stanno generando. In realtà sì, il progetto si svolgerà qui a Roma Tre con una piccola parte di 6 mesi a Milano, in cui c'è questa azienda che è proprio specifica, è specializzata in questo settore, loro testano proprio su larga scala, sui campi, degli estratti.
Comunque quindi in Italia?
Sì, sì.
Altre delle domande da Lore? Ilaria? No. Grazie.
Abbiamo anche l'occasione per ringraziare tutti di essere venuti oggi.
Do you hear me? Yes. Okay. Good afternoon to everybody. My name is Giovanna Di Simone, and my project is focused on the development of a new organ-in-shape systems to evaluate the effect of environmental biological contaminants on onset of pathology of the osteoarticular systems. This project responds at one of the primary objectives of the PNR, that is to improve and innovate the personal care using the holistic approach. The holistic approach considers the interconnections between the state of ecosystems and the state of health of the people. Changes taking place, both environmental, both in the number and compositions of world's population, are causing several and important difficulties in the human health and in the well-being. For the main problem is that environmental contaminants are present everywhere. So they are in the food, in the air, in the soil, in the water, and so everybody come into contact with them. Obviously, the children and the old people that represent the most vulnerable part of the human population are suffer of the worst effect. In this picture, I'll show that by 2050, the 22% of population will be 16 years old. For this reason, the study of relationship between the environmental contaminants and the onset of pathology generally associated with the aging, such as the osteoarticular disease, represent an important challenge of the scientific research. So the bone diseases depend on several factors that depend on genetics factor, hormonal levels, gender, but they also depend on nutrition, lifestyle, and environmental pollution, including metals contaminations. Contamination with metal is an important problem for the worldwide because they are toxic and non-biodegradable. For this reason, they accumulate in the environment and in living organisms, so affecting all the food chains. Sources of heavy metal are here reported. They are in pesticides, they are in the industrial waste, they are in the phone and automobile batteries. So these metals can affect the bone biology. To date, the effect of metals on bone biology is not clear, but it is known that, for an example, cadmium, nickel, and iron can induce the osteoblast apoptosis, but they also induce a bone demineralization. In general, all the metals are involved in an alteration of balance between the bone deposition and the bone reabsorption. For this reason, it is very important to define what is their effect on the bone biology. Another type of environmental contaminants are those of anthropogenic origin, for example, drugs. It is known that drugs are present in the waters. How is this possible? Because pharmaceuticals enter in the water supply by human excretion and poorly disposed drug. For an example, throw down the toilet. So, even if the water passes through the purification systems, some pharmaceutical residues remain. And so the contaminated waters arrive in our houses. And so we drink them, we use them to water the animals and to irrigate the lands. So the aim of this project is to identify risk factors involved in the onset of osteoarticular pathologies by using a 3D organoid models. This will be obtained in collaboration with the Ulm University and with the UFB Ulm Institute, where I will go the next month. But what are organoids? Organoids are three-dimensional cell cultures that show a complexity, an organ complexity that can be considered mini organs. So we will want to obtain bone and cartilage organoid models by starting from mesenchymal stem cells. They will be deposited on matrigel, on hydrogel scaffold, and then they will be induced to differentiate or in chondrocytes or in chondrocytes by using the osteogenic differentiation media. Then they will be used to test our environmental risks, so toxins, metals, and drugs. The second part will be focused on the organ in chip. So we will put this organ on a chip, and then it will be inserted into a microfluidic systems. The vivo organ chip that will be produced by the React for Life company is characterized by uncontrolled and realistic microfluidic systems that emulate the vascular systems, so that emulate the blood in our veins. So Here we have the systems. In this chamber, we can put our organoids. This tube represents the microfluidic systems, so represents our veins. Here, the media can be also a media with physiological condition, or it can be improved by our contaminants. To better explain the MIVO functionality, I show you this video. So, here we have the chamber, the microfluidic systems. In this case, we can also study organ-organ crosstalk. In our cases, we won't study the crosstalk between the organoid, so bone or cartilage organoid, and the vascular systems. Finally, in collaboration with the IHP Leibniz Institute and with the Nanostructured and Nanosciences Unit of Roma Tre, we will also to obtain functionalized surfaces able to induce the mesenchymal cell differentiation into osteocytes and chondrocytes. And then these surfaces will be analyzed in vitro by using the 3D organoids or ex vivo in the microfluidic systems, the MIVO microfluidic systems. So, in general, the green soul of this project is not only to identify the environmental and biological risk involved in the onset of osteoarticular disease, but is also to use to conduct this study, the 3D organoids. Organoids was born in perspective of a reduction, a progressive reduction of the animals required to test in vivo the toxic effect. Moreover, advantages in the use of biological substitutes is in their ability to be integrated in the tissue of patients, thus reducing hospitalization time and healthcare costs. That's all, and thank you for your attention.
Grazie della presentazione. Vediamo se ci sono domande. Grazie. Quindi c'è un chip che simula
Allora, praticamente, diciamo che gli organi in chip sono di nuova generazione. Finora quelli che sono stati messi sono stati messi a punto riguardano prevalentemente il tratto gastrico, perché per esempio per questioni di tempo non ho avuto modo di spingermi un po' di più, però per quanto riguarda l'osso, poiché la biologia dell'osso è molto complessa, ad oggi ancora non si sa molto bene come procedere con la produzione, insomma, degli organoidi di tessuto osseo e di cartilagine. Nell'immagine dove mostravo il MIVO chip, in realtà in realtà gli organi in chip che generalmente si trovano sono questi, cioè nel senso sono delle camere molto più piccole dove all'interno possono essere inserite un numero piuttosto ridotto di cellule. Diciamo che la parte innovativa del sistema MIVO, che viene prodotto per l'appunto dall'azienda dove andrò a trascorrere un periodo, è sia la possibilità di avere delle camere più grandi nelle quali possono essere inseriti sia sistemi tridimensionali come gli organoidi, oppure possono essere inseriti ad esempio proprio tessuti di paziente. E il sistema microfluidico, insomma, può emulare, ovviamente nel momento in cui lo fa circolare tramite il sistema microfluidico in una maniera controllata, perché si può controllare il flusso, è possibile praticamente andare ad emulare quello che succede all'interno del sistema vascolare. Era questa la sua domanda? Grazie.
Allora, prego.
Devo chiedere se questo sistema programma operativo in protocolli terapeutici?
Allora, per quanto riguarda, cioè, non lo so, quindi non so risponderle, insomma. So che diciamo, è stato proposto negli ultimi anni e quindi di conseguenza gli studi e soprattutto gli studi, da quello che ho letto, insomma, gli studi che vengono condotti sono stati fatti su tessuti tipo di paziente oppure però non so che tipo diciamo, di drugs è stata eventualmente testata in questo modo, però si sta andando in quella direzione.
Quando si riuscissero a disegnare e a creare dei nanomateriali che sono in grado di assorbire alcuni inquinanti, sarebbe possibile usare questo modello per vedere se questi nanomateriali veramente fermano la diffusione degli inquinanti?
L'obiettivo finale dovrebbe essere quello. Noi ce lo auguriamo, sarà quello. Grazie.
Grazie, Prof. Bologna. First of all, I would like to thank all the people they organizing this as, I would say, PON program, from the dean to the secretary, because now managing those things is very difficult and challenging. And especially, I think also Ilaria for gathering us today to talk about this project. So now I will tell you more than story, because you told us in your email, try to inspire us about science. And I'm also a forum of biodiversity at this university, because today I will talk about study of microbial biodiversity in Rome underground cavities toward identification of pollution, of biomarkers, and potential bioremediation. I remind you that this project is designed to be collaboration with this company, Gene ProBio, and I'm working under the supervision of Prof. Paolo Visca. So it doesn't work. It's weird. No, now it's fine. Allora, who is Alif Chebbi? Alif Chebbi, I grew up in this city. My name is Alif Chebbi. I have a PhD from the National School of Engineering in the isolation of bacteria able to degrade the pollutant and the production of biosurfactants. So I made like several training abroad in France, UK, and then I went to this beautiful 4 years of my career to Milan. I made three postdocs, and this is Bicocca University. I worked in Criamo project. I worked in several projects, and then by chance, let me summarize first my expertise, because more or less we are. It's also the time to make like networks and to work in some projects. Let's say what I work at the biodegradation of mercaptans, pollutant, developing some anti-biofilm agents, biofouling. Genomic analysis, more or less. I followed the degradation of chlorinated compounds here in Italy in some contaminated aquifers and groundwater. I worked also on the growing interest. Ilaria talked about the circular economy, how to valorize wastes and to produce biosurfactants to enhance the process of bioremediation of soil. So why we work more or less about this topic, actually to propose more or less more eco-friendly and sustainable strategy, I would say, various going from physical, chemical, biological method, I would say from terrestrial to marine environment. You know, all of you, this story. I more or less, I have expertise to work with this kind of green agents coming from bacteria. It's gram-negative, they are rhamnolipids, but most of literature, they use Pseudomonas aeruginosa, and we developed here in Milano to work with some safe strains like Burkholderia and others. And they have several, I would say, applications, more or less. And here I realized Italy, there is no companies producing biosurfactants, and company here, they spend a lot of money to ask for biosurfactant to treat some contaminated soils. Anyway, so this is more or less the concept of circular economy that we developed in Milano Bicocca, that we started from main rhamnolipids with safe character to produce from wastes going from vinaca, wine residues, and all to produce some biosurfactant with safe and eco-sustainable. So the idea is like, most of you that the idea is like when you have leakage of hydrocarbon, we have this plume going from low molecular weight hydrocarbon to heavy molecular weight, and you know that we have several families, aliphatic hydrocarbon, polyaromatic hydrocarbons, so chlorinated hydrocarbon, and we know this is problematic. We found it several here in Italy, like in Brindisi and Ferrara and so on. So the idea is like also to merge or to link the story of circular economy, because here we don't need to extract. We go directly with broths with large scale and to treat contaminated soils using several technologies. I know that we have a colleague, she will talk about nano remediation, but anyway. So I come here to this university to work on, under the supervision of Prof. Paolo Visca, and this is warm team of microbiology. I am here also, I found that there is a man, he's a biologist with us, Paolo Torrini. He made great work in caves, and they have expertise. He went to this place in the world to go deep and take some samples and to study the ecology. This is really surprising and inspiring also. So let's talk about the pollution. You know all of us that I'm not presenting for you to talk about the pollution in Roma, but we just know that we are surrounded with various sources of pollution. We know that the tanks, we have them everywhere here in Rome. And there is like various sources about the pollution without talking about this is toxic compound, the polyaromatic compound, they could induce cancer and so on. I saw last week a publication, the first time they detect microplastic in our blood, and people there worried anyway. So just the idea, it started before I came, the Prof. Paolo Visca, with Paolo, they started, okay, let's go to some caves here in Rome, and maybe we can try to I would say, to link the microbial biodiversity and the presence of certain pollutants. And this could help us first to identify and distinguish certain sites contaminated, to preserve the biodiversity, and we could generate some databases also about some, I would say, caves here in Rome, and so on. So for sure, you need to see some, I would say, main ecological drivers. You could take them into account: the history, rock nature, darkness, oligotrophia. For sure, oligotrophic condition, you cannot find higher biomass. The presence of certain pollutants, they could shape this is biodiversity, and we will try to, I would say, to hunt certain families of pollutants like hydrocarbon, chlorinated compound, and some others. So this is the idea. It was like this, but then we need to see the link more or less between the normal caves that we found in nature, the monstein caves, sulfidic caves, volcanic caves, and also Paolo could tell you a lot about this story that we don't have like normal databases and so on to study, especially the biodiversity and the ecology of those caves. So here we try to put another knowledge. We will study the biodiversity of urban caves, something new, more or less, and we don't see a lot, even in Europe, urban caves, especially from historical sites like we have here in Rome. So anyway, so we selected several sites here in Rome in collaboration with Roma Sotterraneo, depending on the rock nature, I would say the position, and even this society, they know exactly where we found pollutant, and maybe we can find some contaminated sites and so on. The main approach was like this. It's very basic. We will go and to do some physicochemical characterization, water and sediments. We will try to I would say, to test several families of pollutant, like I said earlier, hydrocarbon, chlorinated compound, and others. We will do with, because I worked before coming here in NGS technologies, and even Paolo did, we will try to describe the microbial communities from bacteria, fungi, and others, and we will make like big data related to urban caves, and this is, I presume it's something new. And since my expertise in hydrocarbon and degradation, we will try to go and see some, maybe we can try to find some bugs. They could be helpful for the bioremediation process, and we can develop some added value metabolites going from biosurfactants and other and so on. We hope so. This is research. And finally, I thank you very much. Hopefully this green pond, we see each other another time, and we keep networking. And this is the main, we cannot advance in science without networking. Thank you very much. Grazie. Allora, se non trovo le parole, parlo in inglese.
Allora, grazie. Vediamo se ci sono delle domande.
Allora andiamo, vai. in italiano e poi in inglese.
Ma più legata alle fattori di diverse zone, la seconda quindi diciamo, appunto si parlava di rocce carbonari, rocce vulcaniche, ci sarà quindi un diverso tipo di batteri, di batterica.
Exactly. This is the idea, and this is also Paolo could tell you that when we change the type of rock, maybe we can have another community of bacteria. Now we try to go with NGS technology, and we will try to see the biodiversity and the abundance of certain communities, and then we will see how we can isolate from them.
And also they play different role.
Exactly. Exactly.
Okay.
They play different role. If there is like another factor of selection, it could be pollutant. They could be also during the year of the cycle of the, I would say, the temperature. So you can, I would say, integrate several parameters with it. And for me, I think the most important thing that we can generate databases that could be helped in the future to predict if we have contamination at certain sites, and we go with them and to treat them.
Do you already have an idea, for example, those one in the volcanic caves have a better role which report the other carbonaric one, or you don't know?
So this is only we can, I would say, if we do some comparative study, we can do them against the literature from volcanic caves. But here, in urban caves, we will see. This is an early stage question, maybe we can address them in the future. So that's it, especially if we have a risk of pollution. This is going to be something different, I'm pretty sure. Grazie. Grazie mille.
Mi fa piacere anche perché questo progetto rientra nel Centro Nazionale di Biodiversità, esatto. Quindi mi trovo molto vicino a quello che stiamo facendo da questi giorni. Su un'altra domanda. Allora diamo la parola ad Andrea Sembroni.
Good afternoon, everybody. My research project will be focused on the impact of extreme events related to climate change on mountain areas. The project is carried out in collaboration with the EGEOS SPA company, a national and international leader in territory and satellite image analysis. In 2003, Europe experienced an historical heat wave, which was responsible for at least 3,000 deaths in France alone in the summer. In the Alpine Arc, exceptional rockfall activity has been reported, especially at high elevations. Such an event was a sort of turning point for the study of the effect of climate change. In fact, as you can see from this graph, the interest of the scientific community on the coupling between the extreme event related to climate change and hydrogeological events increased, let's say, exponentially, leading to the publication of a lot of studies which confirmed the existence of such a relationship. The heat wave of 2003 was not an isolated case, but was part of a wider phenomenon, which is called global warming, which in short is a long-term heating of the Earth's climate system since the pre-industrial period. It has been estimated that since 1850, human activities increased the Earth's global average temperature by, let's say, about 1 Celsius degree. A number that is currently increasing by 0.2 Celsius degree per decade. In the graph, you can see here the increase in comparison with the average temperature of the period 1951-1980. What does climate change imply? Here on the right, you have an example of the effect of climate change on a parameter such as temperature. In the graphs, you have in the x-axis the temperature, and the y-axis the probability. So climate change can be manifested by an increase in the average value. So you have a shift of this Gaussian curve with the occurrences of more, let's say, hot extreme events. But it can be manifested also with an increase in the variance, let's say the variability of our parameter. So you have here a flattening of the curve. So you have much more cold and hot extreme event. In the case of the global warming, you have both an increase in the average and in the variance. So in short, the climate change caused and is causing an increase in the frequency and intensity of hot extreme events, let's say. Climate models predict that Earth's global average temperature will increase by 4 Celsius degree in the 21st century if greenhouse gas level continue to rise. But with swift action, the increase will be only 1 degree, about 1 degree. You may think that an increase by 3 or 4 Celsius degree is not a big deal, but let's take a look at this image from Gutierrez et al. 2021 that was used in the last report of IPCC, which shows 2 scenarios. One with a global warming of 1.5 Celsius degree, and one with 3 Celsius degree. In the upper panel, you have the increasing number of days with temperature higher than 35 Celsius degree. In the worst scenario, you have more or less all the countries at our latitude with an increase in days with temperature higher than 35 Celsius degree of more than 40. In the lower panel, you have the change in percent of the maximum daily precipitation. And again, in the worst scenario, you have more or less all Europe with an increase in maximum daily precipitation of at least 5%. Such phenomena have an impact also on other aspects of climate. For example, a warmer temperature will cause the water cycle to speed up because of an increase in evaporation. So, more evaporation leads more precipitation. A warmer temperature will cause the melting of snow and permafrost, and again the rise of sea level. Of course, all of these impacts have an influence on life in seas and on land. So it is crucial to fully understand the climatic influence on geomorphological and hydrological phenomena. But given the high number of studies about this topic, why we are asking the same question? What are we still missing? We do know that phenomena influencing slope stability of mountain areas are precipitation, snow melting, temperature changes, earthquake shaping, volcanic activity, and human actions. We know also that precipitation and temperature changes are the one influenced and controlled by climate and its variation. In general, more extreme events lead to an increase in river discharge and an acceleration in soil separation, which cause landslide triggering. However, the problem is that such extreme events are difficult to predict and extremely variable in space. Similarly, an increase in temperature causes glaciers retreats and permafrost thawing, which in turn leads to depth stressing, thermal stressing, and frost cracking, which of course, are able to trigger landslides. But failure can occur year to millennia after the climate change. There are some researchers, for example, that claim that the large landslides we observe today in the Arctic Arc are the result of the warming after the Middle Ice Age. So we are talking about 2 centuries ago. We know also that landslides response to climate change, depending on the size and type, and also on the initial and current stability condition of the slopes. In particular, for stable slopes, climate variation influence the landslides preparatory factors, so such as antecedent rainfalls, weathering, and so on. For unstable slopes, they affect the landslides triggers, so precipitation, water table rise, runoff. So what to do then? In order to understand the influence of climatic variation on slope stability, we have to map landslides. And also to analyze the spatial temporal evolution in comparison with the geomorphological configuration, temperature data, and precipitation events. Usually, the studies about the impact of climate change on landslides is mostly attempted adopting an empirical modeling or combined approaches. The empirical approach is just a comparison between catalogs of landslides, let's say, and climatic records. Then statistical analysis is made in order to find correlation or relationship between the 2 databases. The modeling approach starts with a global climate model, by which we can derive long-term rainfall or other parameters in order to use them as input in slope stability models. In our project, we will use mostly an empirical approach. And we hope also to enrich such approach with atmospheric modeling. What about Italy? We talked about the Earth in general, but what about Italy? In the last 10 years, Italy has seen an increase in damages due to extreme events. In particular, we counted 946 calamitous events, so in general, floods, landslides, tornadoes, and droughts, in more than 500 municipalities with 251 fatalities. For example, rainfall is becoming more and more intense and dangerous. For example, here in this figure, you have some data of some localities here, and as you can see, the daily precipitation in some cases exceeds the monthly average precipitation by a factor of 2 or 3 in some cases. Such phenomena is followed by usually by landslides and floods, which, in addition to undermining the safety of people, have also a strong impact in terms of the economy, also regarding the social aspect. The research project will be focused in the central Italy, in the Lazio Abruzzo region. Why we chose this area? Basically because it is fully studied from this point of view. Even if there is a detailed database of landslides and floods, basically in Italy, this kind of studies has been carried out mostly in the Arctic Arc. The aim is to understand how the variation in frequency, intensity, and spatial distribution of extreme event and the modification of meteorological parameters, chiefly temperature and precipitation, can affect the natural environment and man activity. In detail, the methods comprise the acquisition of data related to extreme events, meteorological parameters, and geomorphological events. This data will be analyzed from a statistical point of view in order to see relationship, to find relationship between data. For example, I put here a rainfall threshold, which indicates the rainfall, soil moisture, or hydrological condition that, when reached or exceeded, are likely to trigger landslides. In parallel, we will study also topographic map, aerial photos, and satellite images in order to catch the natural and anthropic landscape and identify the effect of extreme events. This step will be very important because by this analysis we will also identify some key areas where to perform some field activities in order to see the effect of climate change, extreme events at the local scale. The results will allow a more accurate assessment of the hazard and susceptibility of the study areas to geomorphological phenomena, and the realization of thematic maps. They will also allow the acquisition of a greater awareness of the vulnerability of a country, in particular of Central Italy, allowing a better land management and resilience policies with respect to climate change. Thanks for your attention.
Un'altra cosa soltanto molto, cioè, diciamo, la parte quindi di monitoraggio, quindi, diciamo, dei trigger, quindi fattori esperanti maximi nel tuo progetto, sarà una parte legata, diciamo, a fare delle opere quindi per mitigare questo rischio, o no, semplicemente la parte, diciamo, della previsione del rischio stesso, quindi dei modelli per la valutazione?
È solamente, per adesso è solamente, riguarda solamente sì, la parte relativa, capire quali sono le zone interessate da frane e capire soprattutto le relazioni, come dicevo prima, con i parametri meteorologici. Uno dei prodotti che saranno appunto realizzati saranno mappe di suscettibilità, quindi sarà il mezzo principale con cui cercheremo di capire la vulnerabilità dell'indicatore centrale a questo tipo di fenomeno.
Collego a questo, mi domando se avete calcolato il problema della copertura vegetazionale.
Assolutamente.
Nell'uso del suolo. È vero che noi abbiamo visto fenomeni come quello del calore dove è passato un tornado, però è vero anche che lì c'era un uso sbagliato come era stato fatto la piantagione di alberi un secolo fa. Però vedendo per esempio situazioni di boschi naturali o situazioni di agroecosistemi, penso che sia un parametro essenziale.
Assolutamente.
Le frane, insomma.
No, l'uso suolo è un parametro predisponente, assolutamente. Assolutamente.
Ti dico, io sono della zona di quella Liguria, Piemonte, Alta Laroia, dove nel 2020 a ottobre foreste estesissime, ma è stato un disastro totale, quindi contraddico me stesso, non è detto che quello che sta succedendo, anche una sana copertura vegetazionale ti permetta di bloccare il traffico. Altre questioni? No, grazie.
Grazie a voi.
Okay. First of all, thank you for staying here to the end. I'm very proud of having you right now. And then I'd like to show you my project that is based on on making a feasibility study for employing low enthalpy geothermal energy in the Bagni di Tivoli Guidonia area. I would like to tell that this kind of study will be a test site. So this is a test area, and I would like to why this kind of application. And this kind of project is made with the collaboration of the Centro per la Valorizzazione del Travertino in the Tivoli area, and with the GFZ in Potsdam. First of all, we know that actually there is a lot of energy that is stored within the Earth, and this kind of heat has a surface expression that we are very used to know, like volcanoes, or if we are I mean, lucky to go to the Yellowstone or Iceland as gas. But what we want to do with this kind of heat is to use it for a production of energy, or for heating or cooling our buildings. First, we need to check what we mean when we talk about geothermal, because there are two kinds of energy that we can use. One based on a high enthalpy, that actually is the measure of the energy stored in water or steam, in this case, that can be high or low, changing as a function of the source and the use that we can do with this kind of heat. With the high enthalpy, we usually have steam-dominated systems that are used for electricity production, while with low enthalpy, we use this kind of heat in water-dominated systems for heating or cooling. The latter is the one that I'm going to use for this project, but I would also like to spend a few words about the high enthalpy. Luckily, we are in the top 10 countries for the geothermal use. This is 2 years old, but I think it's kind of updated. But what I would like to highlight here is that exists a difference between the capacity that we are using and the energy that we are planning to use, or that we have as a resource. In our country, we have 0.5 to 1 to the 9 tons of oil that actually correspond to 5.8 or hundreds of thousand terawatt per hour. But we actually need nowadays only I mean, speaking of this kind of number, only 300 terawatt per hour. So there are almost 3 orders of magnitude of difference between what we could actually have and what we actually need. Still, we use only 5% of geothermal energy as a green energy. But you have to take this kind of number very carefully, because we cannot use all the energy that we have for technology issues, for problem, for actually catching the source. Still, in Largerello, Tuscany, we have one of the first geothermal plants that was built in 1913. Now, coming back to the main target of this project, we can use the geothermal low enthalpy for heating or also cooling of the building. So we start from a source area where we actually heat our water that is pumped inside these insulated pipes. Okay, but now we have to think which kind of source we have for heating the water that after is pumped here. We may think about coal, we may think about biofuels, gases, also nuclear plants, but this is a fun project. So what about something a little more green? Okay, so we are in Italy, so we can use solar panels that use the solar waste to heat water, or we could actually use the geothermal energy. And the geothermal is kind of fancy because we can have a bimodal way of using this kind of approach, because in winter we can use the hot water for heating our houses or buildings, but in summer we can use the same water for cooling them, because if you think about water at 20 to 25 degrees Celsius, it's hot enough in winter, but it's cool enough in summer. So how actually we can use this kind of geothermal energy? We have a recharging area, so the water coming from rainfall, hopefully, that infiltrates into the crust. We have water circulation, and this kind of fluid is heated by a hot body that could be, for example, a magmatic body. So these fluids are heated, are used by a geothermal well, and then are re-injected into the crust. So we are using energy, we are extracting heat from the water, then we are re-injecting water into the crust. So this is a potentially infinite kind of approach, okay? So this is a true renewable source of energy. Moving to the target area, I would like to tell you that this kind of approach is not new, okay? It's only something that is not very used in our country, because if you look in Ireland, Chile, Germany, Greece, Australia, Austria, USA, China, that is a great investor, it's something that has been already done. So we move in the Tivoli area, in the Bandi Tivoli Guidonia area, and we have to define a structural definition. We have to do a structural study of the area. Why this? Because we have to check how the water circulation happens in the crust, okay? So we need to follow how the rainfall comes into the crust and how the water, the heated water, comes at the surface from the deepest part. So we have to do a very detailed hydrogeological study, but we also have to check if or if not this circulation is a problem for the surface. So if we have an active deformation of the area, not only because of the brittle structures like faults or fractures that are in the area, but also for phenomena that are due to the water circulation. This is the study area, it's the Acque Albole Basin, that is about 20 meters above sea level, and it's characterized by the presence of different brittle structures. So this is a pull-apart basin, something that is pulled down by the activity of these faults, and this is a subsiding basin. So it's something that is going down through time. Why this, I'm going to tell you. But you may notice here that there is a quite active quarry area for the travertine cultivation. And you may think that this is something that is not connected to the geothermal energy, but actually it is, because in this case the circulation of hot fluids, highly mineralized, is responsible for the deposition of this very nice rock, okay? And also because the industry there needs to pump water to extract this kind of rock, because the rock is under not sea level, but it's under the water table. So they need to pump water like 2,000 liters per second to lower the water table to get this kind of rock. But then that water is wasted into the Aniene River. So if we look at the water, we see that it's highly mineralized, because this is the conductivity of the water, but it's also hot water. Okay, it's above 20 degrees in this kind of white spot. So we could actually use that water instead of wasting it, and we could do that thanks to our industrial partner. But we also need to characterize the area, because we need to know where the water is recharged, how the water from the Cornicolani Mountains and the Lucratini Mountains go in the deep, how the Colli Albani volcanic district heat that water that is then that springs then in the Acquealbule basin. So we also have to check for a little stratigraphic setup of the area. Finally, we have to prevent all the issues that are linked to this kind of fluid circulation, because that area is characterized by a strong subsidence. As I told you, this kind of green spot means that zones are subsiding, but also we have sinkholes. All these red circles here means some rupture, let's say like this, in the surface, or something that is going down very quickly, that actually is very dangerous for the buildings. So you may think of a house built here, then someday it goes down. Okay. So this water circulation is very good for the energy, but it's also dangerous for the area. So we have to find a solution for having all the good sides and the bad sides. Concluding, as I told you, first of all, we have to define a geological analysis for the fluid circulation, for the bridge structure. Then we have to make this feasibility study for exploiting the geothermal energy. And finally, we have to propose a requalification project for the area. And that's all. Thank you.
Una legata al fatto, comunque mi collego un po' alla presentazione precedente, riguardo quindi a questi fenomeni ormai, come dicevamo prima, piove poco, ma quando non piove sono grandi numeri, quindi uno, questo sicuramente increserà sia sulle falde, ma anche appunto legare a tutto il problema di cui parlavi, di quello che è il rischio di disinfo. Avete qualche idea su, diciamo, quelli che potrebbero essere degli aspetti per mitigare questo rischio?
Questo purtroppo è un qualcosa che non puoi fare, perché tu hai una certa quantità di pioggia che piove in giorni, ormai in poche ore, che in gran parte non va a infiltrarsi nella falda, ma ovviamente esce, e quindi anche qui tu quello che puoi fare è cercare di ricostruire dalla quanta effettivamente acqua va a ricaricare il tuo sistema, e quindi quanta ne puoi sfruttare poi per l'energia. Ma mitigare il rischio in questo senso è un qualcosa che viene prima, quindi conoscere quali sono le zone a rischio e evitare un'intensa urbanizzazione dell'area, cosa che mi sembra sia troppo tardi. Quindi quello che va fatto è, diciamo, anche qui sviluppare una coscienza del luogo in cui si vive e informare dei pericoli.
Thank you very much for that presentation. Just one of the question, maybe suggestion briefly about the physical chemical characterization of the water.
Yeah, sure, of course. This I can tell you on this for the time. I mean, but of course we have to chemically characterize the water always for this kind of problems. Because when you project something that wants to use water, you have to know which are the chemical components that are inside the water, and because you have to be ready for treating them. So yes, of course.
Maybe another role is that we can send microbial community also in the future.
Sorry?
Microbial communities.
Yeah.
Energy could be another project.
Yeah, nice.
Especially now they have a big data.
Good. Sorry, with the mask on, I couldn't hear.
Io volevo
volevo sapere, scusa una cosa, non ho capito bene, l'acqua che usi per riscaldamento e raffreddamento dove sia, ma perché la devi tirare fuori dal suolo completamente e poi che fai? La rimetti in loco nel suolo?
Sì, perché tutti questi banconi effettivamente sono sott'acqua e per poter essere estratti loro devono pompare acqua. E quest'acqua ora viene rigettata fuori, ma altrimenti può essere utilizzata per scaldare o per...
Però bisogna tirarla fuori dal suolo per scaldare, cioè...
ma lo fanno già loro.
Sì, loro lo fanno per lavoro.
Sì,
No, io pensavo anche per utilizzarla anche per attività, per produrre energia, insomma, tanto comunque deve uscire. Non so perché mi ricordo anni fa che Funicello mi raccontava che qualcuno di voi ha conosciuto che se infilavi sotto le case a una certa profondità o qualcosa del genere, era già sufficiente per scaldare la casa in qualsiasi luogo. Allora immaginavo una situazione dove acque più calde, non caldissime, ma più calde, che si potesse utilizzare anche senza tirarla fuori dal suolo, perché il problema è tirarla fuori dal suolo.
Alcune risorgenze.
Esatto. Passato qualche anno.
La temperatura del sottosuolo è praticamente gradi, l'informazione che quindi queste cose stanno in mezzo.
Ma ci sono...
Questo è un sistema un pochino
Ma ci sono zone qui dove c'è una risorgenza naturale. Sì, quindi...
No, ma mi domandavo anche da un punto di vista biologico, appunto, l'effetto che può avere tirare fuori dal sole tutta quest'acqua. Se ognuno è deformato nella sua testa.
Cioè, no, però è un problema che è strettamente connesso anche a questo.
La fauna di...
Uno degli effetti si vede benissimo con l'abbassamento che c'è in terreno. Riguardo al problema di rifiuti è un problemone, ci sono degli interessi sotto troppo grandi per poter ridurre il pompaggio, che è quello che si dovrebbe fare, ridurre il pompaggio dell'acqua.
Permettere alla falda di tornare.
Il pompaggio dell'acqua, o i lavoratori si mettono una mascherina e un po' il bloccaggio del caldo sott'acqua.
Per farla andare sotto si deve consumare energia.
Che può essere estratta dallo stesso sistema.
Insomma, è un po' complicato.
Vedremo. Compenserò tra 3 anni.
In realtà c'è un calcolo di quale sia l'effetto, cioè il limite massimo di quale uno si può spingere senza dover turbare il sistema.
Sì, perché uno può fare una stima di quanto abbassare la falda poi abbia un effetto in termini di subsidenza o di insomma, fenomeni più localizzati. Però è un qualcosa che non si può calcolare empiricamente, ma deve essere visto diciamo, a seguito di prove che vengono fatte in quest'area. Quindi la threshold è un qualcosa che va visto lì per lì, mettiamola in questo modo.
Good evening, I'm Sara Del Galdo, and I'm going to briefly introduce you the main context of my project about the design of polymeric smart material for water treatment. I will briefly outline a roadmap for the project, especially focusing on my role on it. So, nowadays, the world is facing a huge problem, a huge issue with scarcity of drinkable water. This is because not only fresh water is just a small amount of the total water on Earth, but also because many of this, so much of this water is utilized for industries or domestic use, agriculture, hence only a very tiny amount is available for human consumption. But at the same time, the wastewater increases both from industries or domestic use. Hence, the need for some remediation technique to convert and transform wastewater into drinkable water. According to the kind of pollutant that you have in water, different remediation techniques are available based on either physical or chemical or biological approaches. Recently emerging technology that showed to be quite effective is nanoremediation. Nanoremediation is basically the use of nanoparticles for environmental remediation. A nanoparticle is a particle which is small. They have an average size between 1 nanometer and 100 nanometers. This means that they are light. They can freely diffuse into, for instance, water. But the main characteristic that make nanoparticles effective is the high surface per unit mass, which is what makes the nanoparticle so effective with pollutant that will interact with this surface. A kind of nanoparticle, a general class of nanoparticles, is composed by polymeric macromolecules, and especially polymeric nanoabsorbers that can be either purely macromolecules composed by just polymers or polymers grafted on some hard core. Why polymers can be so effective in this? Because this can be designed and tuned to perform predetermined tasks and also to be sensitive to external stimuli. This can be done, this tuning can be done by what is called functionalization, which can be either chemical or physical or both. So you can have the simplest architecture given by, for instance, single branch of polymer with very simple chemical complexity, homopolymer. But increasing this level of complexity, you can reach very complex architecture made by heteropolymers. Sorry. Recently, the researchers in the group where I'm currently working developed an effective nanoparticles able to interact and absorb heavy metal ions. These nanoparticles were made by supermagnetic nanoparticles grafted with thermosensitive D-block copolymers. So, the D-block copolymer part, this is the name, the polymeric part interacted, absorbed the heavy metal ions, and hence exploiting the responsiveness towards external magnetic field, the nanoparticles could be removed from the solution, meaning just with a magnet, as shown in the picture. This study were done both experimentally, as shown in the temp image and the calorimetric data, but also theoretically through a theoretical computational approach. But what was lacking was a deep understanding of the atomic and molecular level properties that made the interaction with the heavy metal ions so effective. And this is where I will be part of. So the aim of the project is the design and characterization of polymeric smart material to treat water, pollutant in water, by means of a combined experimental computational approach. That is, at the same time, we will run in parallel experimental characterization and theoretical computational characterization of polymeric candidates. We will start with polymeric scaffolds that we know that work, that they are effective, and we will change local properties, atomic properties, to check, to see how these local properties affect the macroscopic behavior of the system. So we will start with the simple system, joining the efforts. Then we will go for more complex architecture to see how the global efficiency can be increased by changing the architecture. And at the end, we hope we will come up with the best candidate for water treatment. Generally speaking, to treat different approaches, different theoretical computational frameworks are available according to the system you want to study. The framework of choice depends from the time scale characterizing the phenomena that you want to study and the length scale of the phenomena. So, if you are interested in phenomena occurring at the femtosecond time scale on a very small system, you will go, for instance, for some quantum approaches. But when the size of the system you want to study increase, of course, quantum mechanics cannot be the framework of choice. You have to go for classical schemes. And while you are around 1 or 2 nanometers sized system, you can afford an atomistic description of your system. But when the systems are around 100 of nanometers, you have to go for coarse-grained simulations. With coarse-grained simulation, you group together number of atoms, number of degrees of freedoms, thus neglecting some details that you can imagine not affecting dramatically your system. And different coarse-grained models are possible according to the number of details, the number of degrees of freedom that you neglect. For instance, you can consider a group, you can treat a group of atoms with just the center of mass of this group of atoms. Or you can group together groups of monomers, talking about polymers. Or even you can utilize, let's say, rough models in which your entire system is treated as a sphere or average measure. But the point is that if you start from atomistic simulation, you can develop effective potential to map this complex system into some model that can be more simpler. This effective potential will immediately include the effect of the degrees of freedom that you are neglecting. I will work on the atomistic simulations since during the year I have been working with the molecular dynamics of a system of biological relevance. For instance, relevant to this topic during the years, I've worked on a model to describe protein system both in the native and unfolded state as effective ellipsoids, and then address the characteristic of the hydration of these systems. And very recently, we also studied using the same arguments aqueous solutions crowded with polymeric matrices. But to conclude, going back to the project roadmap, the project will be developed this way. We will start by atomistic simulation of candidate polymer in water, pollutant in water, one polymer Q plus one pollutant in water. We will compare and merge these results with the experimental counterparts. Then we will derive the effective potential and we'll simulate complex scaffolds with coarse-grained simulations. Again, at the end, we will compare and corroborate our results with the experimental results. We will start from the system that I presented you before because we know that it works, and we will start considering as pollutant heavy metal ions. But this general scheme, this way of proceeding is completely general, and we think that we will explore also other kind of pollutants, like for instance drugs, hormones, and antibiotics. So this work will be done in collaboration with the experimental counterpart. For the theoretical computational work, of course, I can have the support of my supervisor, Dr. Barbara Gabone. For the experimental counterpart, Professor Tecla Gasperi, we will synthesize and characterize the polymeric objects that we select. Then the most complex architecture will be characterized and synthesized by the group in Crete, where I hopefully will go. And then when we come up with something that we think that can be ready to be tested on field, we will share our result with the partner. So, of course, I thank all these people for this, all these researchers for this great opportunity to work on this project, and you for the kind attention.
Allora, nel modello non conosco moltissimo il modello molecolare. Comunque, da quanto ho capito, quello che caratterizzare comunque ci sarà un studio del solvente, giusto? E questo, cioè, il numero di molecole di solvente che tu decidi di inserire sul modello computazionale è pari a cosa? L'aerodinamico di questa scelta numerica?
Allora, il solvente, come dici tu, esplicito viene simulato e introdotto nelle simulazioni atomistiche, perché appunto siamo con il problema del numero di gradi di libertà. In quelle condizioni, dato che comunque il sistema è ancora fattibile computazionalmente, si tende a inserire molta acqua intorno al polimero o alla proteina, al singolo soluto, in modo tale da riuscire ad andare a simulare il bulk, non soltanto lo shell di idratazione, per permettere ovviamente uno scambio tra lo shell di idratazione e la condizione bulk, in modo da non creare effetti artificiosi, diciamo, artificiali.
Grazie.
Yes, please.
Just congratulations on this presentation. Finally, someone, I would say, more close to my head. Just one question to this one. It's like the facilities that you could compare. This is kind of say removal of pollutants that you use. Which kind of facility? Chromatography, I don't know, something like this. The final thing, because I faced the same problem here 5 years ago in Italy when I talked with people. This is a real fit, this is technology, but cost effectiveness. Is it sustainable? We can apply it on a larger scale here in Italy, on the side. How do you address this? How do you apply it?
Per quanto riguarda la per quanto riguarda la caratterizzazione sperimentale, sicuramente studi di calorimetria, ma ora diciamo ci stiamo attrezzando anche per cercare di capire se si riesce a vedere qualcos'altro, ad esempio con misure laser, ma comunque sicuramente studi di calorimetria. E per quanto riguarda i costi e soprattutto quanto poi il costo diciamo valga la pena per una produzione massiccia, onestamente non lo so. Se ci può essere diciamo, una richiesta da parte di un'industria nel pensare degli scaffold più economici, sicuramente sarà nostra cura farci caso, ecco.
Posso intervenire? In realtà, actually, the industry that is working with us
is very interested in functionalizing membranes. So part of this project is to take existing membranes that are ultrafiltration membranes, that are membranes that are pores of about nanometer size, and to use the kind of polymers that are synthesized here, so that we can cover those pores and we will exploit the thermosensibility of the polymers, so that you can recycle the membranes, because the thermosensibility, you can use it either to recover some material or to recover the membrane. So it's not obvious that you want to recover the pollutant. Maybe you don't care, but you might care about the use of pollutant, the reason for which Sara is working on that designing very selective polymers. Or you might ignore completely the idea of being selective towards the pollutant, but you want to recover the membrane. So you can use this thermosensibility in order to do that. So actually, the partnership with the industry is to test it. We will build a small prototype on site, because this project is together with the project of Professor Gastin, that has herself a PhD that is working on synthesizing this in another project in China. And the idea is to merge the two projects so that we will actually try to make a membrane, okay, and then further scale up.
No, that's the question. That's because this is the same story with my substance, and I found myself doing life cycle assessment with another word with software that's what we convert them to correct anyway. Look at it.
Posso fare una domanda? Ricordiamoci dalla prima schermata che l'acqua non serve solo alle industrie, all'agricoltura, all'uomo, ma a tutti 1,5 milioni di altre specie di organismi viventi. Quindi avere una quantità di acqua disponibile in tutti gli ecosistemi naturali è una cosa a cui dovremmo iniziare a pensare, che continuiamo a usarne troppa perché ne sprechiamo troppa. È solo una visione antropocentrica della cosa. C'è un problema veramente ormai generalizzato di quantità di acqua disponibile pulita, tutto la chiamata drink, ma in realtà è drink per tutti. Scusa, ho fatto smontare il panno, ci vuole.
Grazie Sara, ci sono altre domande? Grazie Sara. The last speaker of the afternoon, Mariagrazia Leccisi from the Nanoscience Division, that will be parlerà di life cycle sustainability assessment in dispositivi biomedicali e di monitoraggio ambientale basati sull'elettronica organica.
Thank you to the chairman for the introduction. So, as the title of my topic suggests, I will the main material that I will go to assess is biomaterials. So nowadays, as all we know, the current technology is mostly use silicon-based material. The silicon-based material are connected with the use of a lot of plastic. This kind of choice is not sustainable for long future, but even in the short term, because right now we are facing the problem of the electronic waste. And moreover, the needs, the request for this electronic system is increasing, and notoriously, as we know, their lifetime is becoming shorter. So in order to not accumulate all this waste, one possible solution is to use biodegradable electronics. In this case, we have a great potential to reduce the carbon footprint for the use of this kind of system. From the engineering point of view, building a biodegradable electronics is very similar to the traditional one. So we have a substrate, conductor, semiconductor, the electric components, with advantage that these systems are biodegradable. But what does it mean, biodegradability? There are two types of biodegradability. The first one, we have a partial degradation of our system. So for instance, we have a biodegradable matrix while the active material persists. In the second type, we have a complete degradation of our electronic components. But it's worth of notice that for most of application, we just need a type 1 biodegradation, so just a partial degradation of our system. In this case, we can cut off dramatically the cost and the price for their removal from the environment. The science in the last decades developed a huge amount of this biomaterial, polymers mostly, with properties that are suitable for building electronic systems. So we can have insulator, conductor, or even semiconductor. These materials can be both synthetic, as polyvinyl alcohol, polylactic acid, or even natural. Think about cellulose or other polysaccharides, proteins, etc. But both synthetic material and natural material, in terms of biodegradation, they are connected by the fact that the main reaction to degrade these substances are hydrolysis or oxidation. And in order to perform hydrolysis and oxidation, we need two chemical compounds like water and oxygen that are naturally present in our environment. So there is a huge advantage in using these materials. This project will be developed in connection with a tech company present in the Lazio territory, Super Electric, that right now is involved in a bigger project that aims to build sensors to improve the agricultural management. This kind of sensor will, all the microelectronic components of the sensor will be built with biodegradable materials, and they will be connected to a drones that they will shoot this sensor into the ground in order to accumulate a series of biodata to help the agriculture in their agricultural management. So, in order to avoid any kind of ecological impact and the cost of this removable sensor, the choice of biomaterial seems really indicated for this task. We can leave the sensor in the ground, and even maybe the component of that decomposition can be some kind of nutrient for the ground. Maybe. So my work during these 3 years will be to analyze this electronic sample and try to understand the way of their degradation, the chemical pattern, their product. So here I just present an overview of the strategy that they will be developed through 3 main stages. In the first stage, I will try to replicate and simulate the physical-chemical condition of stress of this material. In the second stage, that will be maybe the bigger in terms of time study, I will analyze the chemical composition and the morphology of this material using a combination of spectroscopic and spectrometric technique, and even microscopic. In the first stage, I will analyze all the data obtained from my study, and I will try to understand which are the mechanisms of biodegradation, primary and secondary, and maybe, if possible, propose to the company some new solution in order to increase the lifetime of these components and maybe even their efficiency. So, for the first stage, I will use an instrumentation present in our Department of Science that is an accelerated chamber unit. This chamber unit will allow to accelerate the aging of this material, modulating some parameters as oxygen, temperature, humidity, and of course UV visible irradiation. In this case, I will be able to collect a series of samples at different aging stages, and moreover, I will be able even to stress these samples with unusual high level of physical-chemical stress. For the characterization, I will study the surface characterization of these materials, of this electronic material, with spectroscopic technique as the X-ray photoelectron spectroscopy, that exploits the principle that when the matter is radiated with some electromagnetic radiation like X-ray, it emits electrons. And we are able to, in this way, to assess exactly the chemical composition of the surface of the material, and moreover, not only all the elements, but even what these elements are bonded to. We already started to perform this kind of study, to test the study, and here I presented just brief examples of XPS spectroscopy in which you can easily observe that the two main peaks observed in this case are carbon and oxygen, that are the main components of the biomaterials. And here there is even a picture of the samples that we are analyzing. Another technique that is very useful, spectroscopy technique, because it's very fast, it is the infrared spectroscopy with attenuated total refraction sampling method. This technique, this method of sampling, will allow to analyze our sample without any pre-sample treatment. So our chip as it is under the instrument. This instrument present in our lab is coupled even with a microscopic unit, always working with infrared, that will allow to obtain a bidimensional infrared map of our chip. A more complicated technique, but that will allow us to study not only the surface, but even the inner layer, will be the time of flight secondary ion mass spectrometry. This technique allows to understand the chemical composition of the samples thanks to the secondary ions that are emitted when the ions being from a primary source interact with the matter. Moreover, this machine has a secondary ion that emits cesium ion that physically will exfoliate our multilayer, so we will be able to study the chemical composition even at interfaces. And this will be very important to understand how the gene process affects not only the surface, but even the inner layer. In the end, to study the morphology of our materials, I will use mainly two microscopic techniques, atomic force spectroscopy and scanning electron microscopy, that they are two different working principles, but they have the advantage that their results are complementary. For instance, atomic force microscopy allows to obtain a three-dimensional picture of our samples, and it has a very high contrast for flat surface. On the contrary, scanning electron microscopy provides a bidimensional picture, but it has a very, very high contrast with samples that have strong vertical relief. That if you think about electronic samples that are multi-layer, this can be very, very useful in this sense. So I hope to give you an overview of the strategy of the project and what is the main goal. I would like to acknowledge the scientific reference, Professor Giovanna Iucci and Dr. Luca D'Amato, for the XPS study, Professor Chiara Batocchio and Martina Marsotto, PhD candidate, all the super-electric company, particularly engineer Alessandro Paglialunga and his team, the Dipartimento of Scienze of Roma Tre, and even the NFN that is working with us. Thank you very much to all of you for the attention.
Sì. Yeah. Pay attention because it's not so sensitive, this technique, and you cannot, so especially by variation, you cannot quantify all of this.
No, about the quantification it's very difficult, of course. Exactly. IR spectrum are very complicated, but I mean, in terms of easy, it's about the technique. Here. Yes, that is like that will also think fast measure. But for the ER, my main goal will be like to understand which are the chemical groups, the chemical moieties, and how these will evolve with the aging. So, for instance, how the oxidation proceeds during time.
Questions?
Okay.
Grazie
ringraziare molto Ilaria Fraudentali per aver organizzato questa giornata e penso che sia stato un pensiero personale, penso che sia una grandissima opportunità per tutti i nostri gruppi e tutti noi quella di aver avuto questi finanziamenti per creare queste linee di ricerca che in fondo, avendo una linea comune, possono avere tantissimi punti di contatto. Come abbiamo visto nel corso delle presentazioni, ci sono in realtà tanti punti di contatto tra le varie linee di ricerca che sono state approvate. Quindi penso che sia veramente stata un'ottima idea e penso che sarebbe, personalmente penso che sarebbe un'ottima idea fare magari anche dei sottoincontri per linee di ricerca per riuscire a creare un'interconnessione tra le vari gruppi.
Posso aggiungere, se tu ricordi 3 anni fa, prima del Covid, organizzando la giornata della ricerca del Dipartimento. Fu faticoso, ma fu bellissimo. Adesso lo dico, non lo ripeto, bellissimo. Nell'aula di sotto, un centinaio di persone, dei poster esposti ha rappresentato in quell'anno la nostra ricerca. Oggi ho visto, lo dico per piena società, un unito a quella giornata, piccolo, ma con i nuovi. Allora c'erano molti gruppi di ricerca già consolidati, ma con i nuovi ricercatori. E penso che noi dovremmo adesso, nella situazione forse, speriamo, migliorerà, cercare di ritornare a questo. Parlerò di nuovo del punto di vista. Io non ho potuto negli ultimi anni di lezione fare la seconda e terza della ricerca per motivi che sono ovvi. Adesso, oggi è la prima occasione in cui siamo. Mi dispiace che non posso dare la sua presenza, neanche saranno un po' di più il collegamento. Io vi inviamoci anche al fatto della presenza e per il fatto di avere la comunicazione, lo scambio, come dice l'altra adesso. Vedete quante cose sono intrecciate oggi. E allora di farsi immagino siano state altrettanti per il 2005, no? Ragioniamo e puntiamo eventualmente a una nuova giornata di ricerca in cui si dia spazio a questi nuovi ricercatori, a tutte le nuove iniziative che per di più se sono trasversali come il nostro dipartimento. Questo è il nostro obiettivo. Va bene? Quindi, grazie della giornata, grazie